Simon says subscribe and click on the bell icon to receive notifications.
We've made the accompanying exercise files for this tutorial available for free. Just click the link below in the video details to get these.
Hello everyone, and a very warm welcome to this course on Excel 2021 Intermediate. My name is Deborah Ashby and I'm a Microsoft IT trainer, and I specialise in the design, delivery and facilitation of Microsoft courses both online and in the classroom. And I've been working in the IT industry for about 26 years now, which makes me feel extremely old. And I've been an IT trainer for 16 years. I've also been a certified Excel geek since 1996. So hopefully everything I've just said there qualifies me to be sitting in front of you and hosting this course for you today. And what an amazing course we have for you. This course is designed for the latest standalone version, Excel 2021. And if you're thinking to yourself, well, what does that mean? I don't really understand how these versions work anymore, then you are not alone. Basically, the standalone versions are for people who haven't subscribed to Office 365. With a monthly Office 365 subscription, Microsoft push all of the new updates to Excel out to you automatically. But for those people who don't have an Office 365 subscription, in general, you need to wait for the next standalone release in order to receive those newer features. And that is exactly what we have here. So Excel 2021 is pretty much in line with the current version of Excel for Office 365. So all of those new features that maybe your friends or other colleagues who work elsewhere have been talking about, you now have access to those in this latest version. And we're going to be looking at all of the new stuff, as well as some of the older intermediate skills in this course. So let's dive in and take a look at what we're going to be covering over the next few hours. Well, we're going to start out with an introduction. That is pretty much what we're doing now. And we're then going to move on to our first section, designing better spreadsheets. So in this section, I'm going to go through with you some really important golden rules when it comes to spreadsheet design, which is going to really help keep you organized. We're then going to dive straight into the good stuff, logical functions. So things like ifs, nested ifs, SUMIFs, COUNTIFs, average ifs, all of those really useful logical functions. We're then going to move into everybody's favorite lookup functions. So if you don't know your VLOOKUP from your HLOOKUP, then hopefully we're going to solve that mystery for you today. We're also going to take a look at more complex lookups using things like index and match, and we're going to be taking a look at our first brand new function for Excel 2021, and that is XLookup and XMatch. After lookups, we're going to move straight into advanced sorting and filtering. And there's a couple of new formulas in that section as well. We'll then take a look at those so important date and time functions before moving on to our section on preparing data for analysis. And this is a really important section where you're going to learn some really valuable skills. So again, lots of new formulas to learn in that section, as well as a step-by-step guide as to how to clean your data and prepare it for our next subject, which is pivot tables. One of the most useful things in Excel when it comes to analyzing data. We're going to completely demystify them, take all the hard work out of them, and I'm going to show you just how simple they are when you break them down. We're also going to take a look at pivot charts and how they work with pivot tables, and then we're going to move on to adding interaction to our pivot tables and pivot charts using slicers and timelines. Then the extension of the last three topics is really interactive dashboards. This is kind of where we bring everything together and create ourselves a really nice dashboard to show high-level statistics. We're then going to move into formula auditing. So we're going to take a look at some of the errors that you can get in Excel. I'm going to show you how you can identify them and also how you can fix them. We're also going to go through how you can use some of the really useful features in Excel to audit your formulas. We'll then move on to data validation. I'm going to show you quite a few different examples of the different types of validation that you can add into your spreadsheets. And we're also going to take a look at a more complex example of custom validation. And then in the final section, we're going to explore Excel's what-if analysis tools. So things like goal seek, one variable data tables, two variable data tables, and of course, scenario manager. And then finally, we'll just close out the course and say our goodbyes for now. So lots on the agenda. So before we begin, let's just run over the structure of this course. This course contains 15 sections and 70 lessons. And each lesson contains a video demonstration or tutorial that is 5 to 15 minutes long. And you'll find all of the files that I use in the demonstrations available in the course files folder for you to download. So if you want to follow along with me, just look at the file name that I'm using in the video and you'll be able to find the corresponding course file in the course files folder. And at the end of each section, you'll find a downloadable exercise that you can use to practice the skills that you've learned in the section, along with quizzes to test your knowledge even further. So plenty of resources and ways that you can practice. So with all that said, it is just about time to get started. The only prerequisite to this course is that you have a copy of Excel 2021 downloaded and installed on your PC. If you want to grab yourself a coffee or some other kind of drink, then please do that now, because we're just about ready to dive into the first session. Once again, my name is Deb and I am super excited to be your host for this course. So throughout this section, we're going to start to take a look at some of the things that I mentioned in the previous lesson when we were talking about the golden rules of spreadsheet design. And the first one I'm going to talk to you about is how to use cell styles in your workbooks to help improve readability. And I always find that cell style seems to be one of those things that I don't see a lot of people using, but can be extremely helpful, particularly if you're going to be sharing your workbook with a lot of other people. Cell styles effectively tell people what type of cell they're using. So what exactly do I mean by that? Well, I have my spreadsheet just here. We have some basic data on it, just some invoice numbers for some clients. I have an amount column. I have the amount of VAT. So VAT is 20% of the amount. And then I have a simple sum calculation in column F to work out the total of that invoice. Now, if this is a worksheet that I'm sharing with other people in my team, maybe other people are going to be adding more invoices onto the bottom of this. And I want to make it super clear to everybody who's using this spreadsheet which cells they can type into, which cells contain formulas, which cells are headings, so on and so forth. And I can do that by using color in the form of cell styles. So if we go up to the Home tab, we have a Cell Styles drop-down. And we have numerous different default cell styles that we can apply to different cells in our worksheet. Now, it's worth noting that the colors that you see here, particularly these themed cell styles at the bottom, are all based on the theme that you currently have in use in Excel. So I'm using the standard Office theme, and this is the color palette that comes with this theme. And all of the cell styles are divided down into different categories. And all this really is formatting. So you'll see as I hover over some of these, you can just see behind where I have this drop down, the cell is changing depending on which one of these I've selected. And of course, if you don't like the colors or the format of these, or you have a very specific color palette that you need to use at your organization, all of these can be modified and updated to reflect your own colors. For example, if I didn't like the way that this calculation cell style looked, I could right click, I can go into modify, and I can change the format of that particular cell style. So you can change these. Now, we're not going to do that right now. I just want to show you how in general I would use these in this type of worksheet. So if I take a look at my data, I want to let people know which cells they need to input information into. And that is going to be all of these cells just here. So other people will need to enter in the invoice number, the date, the client, and the amount. But VAT and total are calculated using formulas. So I want to denote these cells just here as input cells. So we're going to select them, go up to cell styles, and I'm going to choose this one just here, input. Now it might be that you definitely do want to go in and change this formatting. A lot of people don't necessarily like this orange background fill with this blue writing. So if you don't like it, just remember you can change that. Now these other two columns contain formulas or calculations. So I'm going to select this group of cells and I'm going to let people know that these are calculation cells. So simply by the use of cell styles, it's fairly obvious to see which ones are input and which ones are calculations. Now this VAT rate over here, I'm going to let people input whatever they need to input into here because that might change. So I'm going to denote that as an input cell as well. And I have a title at the top. So maybe I want to select these cells and denote that as a heading 2. And I could carry on going. I can even create my own new cell styles from here as well. So if you want to create your own, you can definitely do that also. And then what I would generally tend to do is create a welcome sheet at the beginning, which has a legend on it that explains what these cell styles are. So I might put something like input cell. Let's just add 2 of these that we're using. And I might put something like input values into these cells, and then I might have calculation cells, just so it's super clear for anybody looking at this worksheet. So that is basically how you use cell styles. It's simply formatting, which lets other people know what type of data goes into the worksheet and where they should be typing. One of the golden rules that we discussed in the first lesson of this section was how we can control data input. Because again, if you've spent a lot of time working on a spreadsheet and you've put together some really nice complex formulas, if you send that out to a group of people who maybe don't have the level of skill that you do when working with Excel, you might find that it comes back to you full of errors and all that hard work we put in has been undone. Or it might be that you send this out to other people and they start entering in invalid information into the spreadsheet. So we can put in some safeguards which will help keep our spreadsheets as error-free as possible. So the 2 that I'm going to demonstrate to you in this lesson are data validation and also protection. So let's take a look at the data that we're going to be using. Now this is just a very simple list of employees. I have the employee ID, the employee name, the department they work in, and then their salary in column D. And what I have over on the right-hand side are actually a couple of formulas. Now, currently these formulas are showing me NA errors. That's okay, that's going to be fixed in a moment. But if we click on cell I4, for example, and take a look in the formula bar, you can see that I have an index and match formula in there. Now, don't worry if you have no clue what this is doing. We are going to cover index and match in a couple of sections' time. But what we're basically doing here is a lookup. So what I want to be able to do is just above here in cell I3, I want to be able to have the employee name and then have these index and match formulas return the department that that employee works in and also their salary. So the formula is basically going to look at the information in cell I3. It's going to compare it in the table. It's going to find the employee and then it's going to return the department and the salary for the employee that we've selected. Now, if I give this spreadsheet to a colleague and their manager says to them, find out for me the department and the salary for Laurie May. So the employee comes up here, they type in Laurie May and hit enter, and it doesn't bring anything back. Now, the reason why it's not bringing back the correct information is because the employee has spelled Laurie incorrectly. It should be L-O-R-I. So instead of that employee going back to their manager and saying, couldn't find any details, or the spreadsheet wasn't working, which could reflect badly on you if you put the spreadsheet together, you want to make it so it's impossible for them to select the wrong name. And we can do that by using a data validation drop-down list. So what we're going to do here is we're going to click in cell I3 let's go up to the Data tab and into the Data Tools group. Now, if we click Data Validation and Data Validation again, it's going to open up this little dialog box. And we want to be on the Settings tab. If we click the drop down underneath Allow, you can see that there are a few different options in this menu. Now, the one that we want is List. We want to create a drop-down list of all the employee names so that other people can select them. Once we've selected List, we then need to provide the source for our list. So what are the names that are going into this list? Now, my names are listed in column B in this table, and they are all unique names. Now, I'm going to show you how you would do this if your list items weren't unique a bit later on. But for now, let's not get too far ahead of ourselves. These are all unique. So in the source field, I'm simply going to select all of the employee names. These are going to be in my drop-down list, and click on OK. Now notice that I get an in-cell drop-down, which is listing out all of those names. So now if the same employee wants to find this information for Laurie, they can simply select them from the menu, and now these formulas are set up in such a way that they're going to look at the value in cell I3 and return the relevant information from the table. So simply by adding a drop-down list, we're controlling what's input into this particular cell and ensuring that our worksheet is a lot less prone to errors. So drop-down lists are a fantastic way of controlling what's going into your spreadsheet. Now, with all that said, what if I want to go a stage further? Maybe I need to send this worksheet out to other people. I want them to be able to select an employee from this list, but I don't want them to be able to edit any of these formulas. Currently, anybody can jump in here and start making changes to these index and match formulas, but I really want to lock them down so that they don't get broken. Now, before I do that, let's just make this a bit clearer. I'm just going to add in employee into here, and I'm going to use my format painter just to copy across that formatting so everything's nice and neat. So what I'm going to do here is I'm basically going to lock down these two cells so that they can't be edited and leave everything else on this worksheet editable. And this is what we call protecting cells. Now, the thing that I always found slightly confusing about this is that it feels like it works a little bit backwards. The concept you have to understand is that by default in Excel or in a worksheet, every cell is locked. Now, this is the part which always used to confuse me because I used to think to myself, well, if every cell is locked, how can I go into every cell and just start typing? Well, it's because the locking doesn't take effect until you protect the worksheet. So the first step here is to select the cells that can be edited and then unlock them. So it might be that I want this cell to be editable so that people can select employees from the drop-down, and maybe I want the table information to be editable as well. So I'm going to select this cell, I'm going to hold down Control, and I'm just going to select all of the information in the table, right-click the mouse, and go into Format Cells. Remember, you can press the shortcut key of Control-1. Now in here we have a Protection tab, and notice by default, Locked is checked. And that is because all cells are locked by default. Now we want to unlock these cells, so let's remove that check mark and click on OK. Now, for all of this to take effect, I need to protect my worksheet. So up to the Review tab, into the Protect group, and we want to select Protect Sheet. Now I'm going to put a password on this worksheet, but notice underneath we have a whole list of basically exceptions to this rule. So I could choose other things that I want to allow users to do in this worksheet. So currently I'm only going to allow them to select locked and locked cells, meaning they can click on the cell. That is absolutely fine. Now let's put a password on here. And then we need to confirm that password. So now what you should find is that I can still do things like select employees from this drop-down list. I can make changes to cells over here because those are also unlocked. But if I try and change these formulas, these two cells, I'm going to get this message. The cell or chart you're trying to change is on a protected sheet. So effectively, I've protected both of those formulas from editing. And again, this is something that is invaluable if you want to keep your spreadsheets as error-free as possible. Now, if you want to unprotect your sheet once you've protected it, just click the Unprotect Sheet button, and you'll need to know what the password is in order to unprotect. Now that I've done that, if I go back in, I can now edit these formulas again. Something that I didn't actually include in my golden rules for spreadsheet design, and probably should have if I'm honest, is making your spreadsheets easy to navigate by adding things like navigation buttons and links. We really want to make our spreadsheets easy to navigate as well as easy to understand. And if you have a particularly large workbook that contains lots and lots of different worksheets, you want to make sure that users have a quick way of jumping to the different worksheets and navigating efficiently between the different tabs. So let me show you a couple of examples, and then you can have a think about how you might implement these. So I've got this workbook here. We have quite a few different worksheets running across the bottom, and it might be, if I go to the sales data worksheet, maybe I want to have a button on here which says something like click here to see analysis. And what I effectively want this button to do is when the user clicks on it, it's going to jump them to the analysis worksheet so they can see the pivot table and the pivot chart that's been created based off of this data. Now, I can implement this in a few different ways, and this is really a stylistic choice which you're going to make yourself. I could just add a piece of text. So if I click just here, and I think in this example, this is going to be a bit easier if I turn grid lines back on temporarily, I could just add a text-based link. So maybe I want to type in, please click here to see analysis. Something like that. Doesn't look particularly interesting, but it does work. I can select this text and I can create a hyperlink to the analysis worksheet. Now we can create hyperlinks in a couple of different ways. I could go to the Insert tab, and all the way over in the Links group, we have a link button just here. Keyboard shortcut Control+K. Now this is going to open up the Insert Hyperlink dialog box, and there are tons of different things you can link to from here. I could link to an external website, I could link to an email, or I can link to a place in this document. And that's exactly what I want to do. So I'm going to select Place in this document. Now notice it brings up on the right hand side all of the different worksheets that I have in this workbook. So it's very simple for me to just select the worksheet that I need, which is analysis in this case, and I can even choose where I want their cursor to land on this particular worksheet. So I'm going to leave this on A1. What I could even do up here is I could add a screen tip so that when the user hovers over this piece of text, it's going to show a little pop-up box that tells them something like where this link is going to take them. So maybe I just want to put jump to analysis worksheet, something like that, and click on OK. So I've selected my worksheet, I've selected the cell, I've added a screen tip. Let's click on OK, and now this is a hyperlink. Notice as I hover my mouse over it, my cursor changes to a little hand icon, and there is that screen tip popping up. So if I click this link, it jumps me to the analysis worksheet, and notice that my cursor is in cell A1 by default. So that is the first method I could use. It works, but it's not particularly interesting. So how can we make this a bit more interesting? Well, we could create something that looks more like a clickable button. And we would do this simply using shapes. So up on the Insert ribbon, let's go to Shapes, and I can choose any one of these. Now, I think I'm going to use this one here, the rounded rectangle. Let's grab that tool. My cursor has changed to a small cross, and I can simply draw something which kind of resembles a button. Now, of course, we have all of our usual formatting options on the Shape Format contextual ribbon. So if I want to change the color of that, I can. Maybe I want to change it to something which matches the spreadsheet colors a little bit better. I can change the shape outline. Let's give it a dark green outline. And then I can add some text. Now with shapes, if you've got them selected, you can simply start typing to add some text. So let's say, please click here to see analysis. I don't particularly like the font that's in use in this particular template, so let's change that. Let's go to the home ribbon. I'm going to change this to, let's go with Arial, and I need to make this a bit bigger, and I also might want to move that text into the middle. And of course you can play around with this as much as you like. You might want to make the font slightly bigger. You might even want to add some shape effects to this to make it look even more like a button. So if I was to add something like that, that kind of gives it more of a button look. So now that I have my button created, I can simply click on the shape. I could go up to Insert and choose Link from there, or I could right-click my mouse and go to Link. It's going to pop up the same dialog box. We want to place in document. We want it to link to the analysis workbook, but this time let's choose a different cell to link to. So I'm going to say B10. I could add a screen tip if I wanted to. I'm not going to in this case, and click on OK. So now we have a clickable button. When I click on this, again, it's going to jump me to the workbook. Take a look at where my cursor is, cell B10. And personally for me, that looks a lot more effective than just the text. Let's take a look at one more example, and this time I'm going to use something which was a reasonably recent addition into Excel. I say reasonably recent, they've been around for the past few years, and that is using icons. You can set up links on pictures, icons, 3D models, text, shapes, pretty much anything you want. So if we click on icons on the insert ribbon, maybe instead of a shape, I want to use one of the icons from the icon library. So I'm actually going to search for the word analysis, and let's just use this icon and insert it. I can put it somewhere down here. I might want to add some text to it to make it super obvious as to what it's going to do, but I think you get the idea. Let's just set up our link. This time I'm going to use the keyboard shortcut of Control K to open that dialog box. We're linking to the analysis workbook, and let's choose A5 this time. I will add a screen tip for this one because it is simply an icon. It's not so obvious. Jump to analysis, click on OK, OK again, and now this icon, when we click on it, is going to jump us to the relevant worksheet. Now, as I said, you could insert a picture and set this up in exactly the same way. You could insert a 3D model, a different type of shape, lots of different ways that you can create hyperlinks. One thing I find that's sometimes quite nice to do, particularly if I have a workbook structure like this, is sometimes I like to have just a little icon in the corner which will enable users to jump back to the How to Use page. So again, I might choose to use an icon, and let's just search for a home icon just here. Let's use this one. Of course, I can change the color of this icon so that it matches my worksheet. Might want to make that a bit smaller. I could place that in the corner or somewhere else on my worksheet, and I could copy this across to all of my worksheets simply by doing Control C and Control V. I might want to place this in the corner of all of them. And then I'm going to set up a link, Control K, which is going to jump me to the How to Use page. Let's add a screen tip that says jump to How to Use. Click on OK, click on OK again. When we click it, it's going to jump us to that page. So a few different methods there for creating clickable buttons to help you navigate around your worksheets and workbook. In this section of the course, we're going to dive into the magical world of using logical functions in Excel. Because logical functions are some of the most important functions that you can know or have in your toolkit when you're working in Excel, particularly if you're an intermediate user. And what logical functions help us do is basically make decisions. Now, there are quite a few different logical functions. You'll find them on the Formulas tab in the Logical group of the function library. And you can see all of them sitting in there. And we're going to use quite a few of these throughout the balance of this section. But what I wanted to make sure that we do in this first lesson is just do a quick recap on some of those basics, just to make sure that we're all on the same page and we're starting from the same baseline. Because it's really important to understand the concept behind how logical functions work before we can move on to doing more complex calculations using things like ifs, SUMIFs, COUNTIFs, and nested if statements. So let's talk about logical statements in their most basic form first of all. And we're going to do this using an example because it's always the best way to visualize this. So on this first worksheet, I have a very small table, and this lists out some expenses. So we have the person's name in here, we have the total of their expenses, and what I want to do is work out if an approval is required. Now we have some additional information next to this that says expenses over the following amount must be approved. So if the expense is over $1,000, then it needs to be approved by a manager. So I can work this out by using a very simple logical statement. Now, what exactly are logical statements? Well, it's basically like performing a test. So in this particular example, if we take the first expense just here, I would want to construct a logical statement that says if this value in cell B5 is greater than or equal to this value in cell G5, then it needs to be approved. And I want to perform that same test on all of these expense invoices. Now, when we're doing things like this, we use what we call operators. And you can see I've just pasted in a little picture of a table that shows different operators that you might be using in your logical statements. So things like equal to, greater than, less than, greater than or equal to, so on and so forth. So let's do this first one just here. We're going to type in equals to let Excel know we're about to do a formula, and this is very straightforward. We perform our test. So is the value in cell B5 greater than or equal to, we're going to say that because if it's 1,000 dead on, it needs to be approved. Is it greater than or equal to the value in cell G5? Now remember, if you want to copy this formula down, we don't want that figure in cell G5 moving, so we need to lock it by pressing the F4 key and making it absolute. Now if I hit enter just here, it's given me a result of false. And what I can do is I can now copy that formula down, and I can see here that all of the results showing as true are the invoices that are greater than or equal to 1,000 and need to be approved. Now notice here that all of my answers are either true or false. And if you perform a logical calculation in this particular way using these operators, the output is always going to be true or false. Now that might be absolutely fine for whatever it is that you're doing, but sometimes it might be that you want to make this more meaningful. So instead of it saying false just here, I might want it to say okay. Instead of saying true just here, I might want it to say approval. So effectively what I might want to do is attribute meaning to the true and false values. And I'm going to show you how you can kind of move on from this and do that in the next lesson. But for now, let's just get this concept of logical formulas straight in our head. We perform a test. Now, because of the way that I've set this up, if this threshold in cell G5 was now to change, so maybe this now changes to 1200, notice that all of my results update. If I was to change this to 500 and hit enter, everything is now true. Okay, so a really nice effective way of putting this formula in and making it dynamic and easy to update. Now, just to go back to changing these values and adding meaning to them. In order to do that, instead of just having our basic logical function, we would need to turn this into an if statement. And that's basically what an if statement allows us to do. It's basically this same logical formula, but it allows us to attribute more meaning to the results. And we're going to cover if in a lot more detail in the next lesson, but let me just show you how we would change these values. Now I'm just going to delete these out. Now what we're going to do is we're going to wrap basically our logical statement inside an if statement. Now notice here it says check whether a condition is met and returns one value if true and another value if false. So the first argument here is our logical test. So our logical test is pretty much what we just did. Is this value greater than or equal to this value? F4 to lock. Press comma to move on to the next argument. This is where we can attribute meaning to the true or false result. So it says value if true. I can now define what I want it to say if the result is true. So if the result is true, effectively the number is greater than 1,000 and it has to be approved. So in quote marks, because text in formulas must always be in quote marks, I want it to say approval, comma. If the value in the cell is false, I don't want it to do anything. I just want it to say OK. Let's close the bracket. So I've attributed meaning to the true and false results. Let's hit enter. And I can now double click to copy that down, and it's a lot clearer for me to see which invoices need to be approved. So simply by adding in that if statement, we've changed the rather generic true or false output to something that's more meaningful and easier to understand. And that's basically what an if does for us. Let's look at a few more examples of if in action. Now in this first table, again, a very small table, we have some test scores. So we've got some student names and we've got the score they achieved in a test. And the pass mark is 85. So I want to create an if statement that says if the value in this cell is greater than or equal to the value in this cell, 85, I want a result of pass. If it's not, I want a result of fail. So again, we're going to use if. Our logical test is if the value in B4 is greater than or equal to the value in H3. We're going to copy this down, so F4 to lock. If that is true, then they have passed. Hooray! If it's false, then unfortunately they have failed. Close the bracket. I'm going to do a Control Enter to stay in the same cell. Copy that down and I get my results. So much more meaningful than simply true or false. Let's take a look at another example of if. And we're going to add in a little bit more complexity just here. So in this second table, we have some products, we have the weight in kilos, and then we have the price for those products. And I'm actually just going to change these to dollars just to keep everything in this spreadsheet consistent. Now what we're going to say here is that if the weight of the product is greater than or equal to 30 kilos, then there's going to be a 20% shipping fee. And that shipping fee is going to be 20% of the price. So let's construct our if. What is our logical test? Well, if the weight is greater than or equal to 30 kilos, again, F4 to lock. Now, what do we want it to do if that is true? So if the product is greater than or equal to 30 kilos, well, there's going to be a 20% shipping fee. So our true result is going to be a calculation because we want it to work out that shipping fee. So if it's true, we want to do the price multiplied by 20%. F4 to lock, comma. If it's false, there's going to be no shipping fee. So we're going to put a 0 on the end there. Close our bracket, Control Enter to stay in the same cell. And if I copy this down, I should find that the only two products that have a shipping fee are the ones that are greater than or equal to 30 kilos. And this amount should be 20% of the actual price. So we can incorporate formulas into our logical if statements as well. Now I just want to finish off this lesson by running through a couple of other basic logical statements, and that is and or. Now what and allows you to do is basically perform two logical tests. So we're taking this example of test results again. So we have our students and we have the score they achieved in test 1 and the score they achieved in test 2. And what we're going to say is that they need to have achieved above 75 in test 1 and above 65 in test 2 in order to get a result of pass. So we're effectively performing two logical tests here. So if we want to do more than one, and we need both of these to be true to get a positive result, we use the AND formula. Notice the arguments logical 1, logical 2. So our first logical test is if this score is greater than or equal to the pass mark for test 1, F4 to lock, and the second test score is also greater than or equal to the pass mark for test 2, F4 to lock. Both of those have to be true in order to pass. Now I'm going to hit enter. It's going to give me a result of true or false. If I want to add meaning to this and have pass or fail, I would need to edit this formula and wrap it in an if statement. Remember, that is how we add meaning. The first argument for our if statement is the logical test. Well, those are being generated by our AND formula. So I can go straight to the end and just define what I want it to say. So if both of those are true, it's going to be a pass. If both or one of those are false, it's going to be a fail. Close the bracket, hit enter, and now I've combined two functions together to perform two logical tests, and I've given them meaning using if. All works in a very similar way, except what we're saying here is that they need to have achieved the pass mark in test 1 or in test 2 in order to achieve a result of pass. So we're going to go straight in and type in our if formula. Our logical test, well, we want to generate this using our OR calculation. Logical 1, logical 2. So if score 1 is greater than or equal to the pass mark, F4 to lock, or score 2 is greater than or equal to the pass mark for test 2, F4 to lock, close off our OR, we're now back into our if statement. We can now set up the value if those are true. So if that's true, we have a pass. If it's false, we have a fail. Control, enter, and then I can copy that down. So notice here that the only one that comes up as fail is where both of these scores are less than the pass marks. So we've looked at basic logical functions there. We've seen AND, we've seen OR, and we've seen how we can add meaning by using if. And in the next lesson, we're going to look at if statements in a lot more detail. In this lesson, we're really going to isolate that if function and take a look at it in a little bit more detail. Now, we saw in the previous lesson some basic uses of if and how we can use if to add meaning to true or false results. Now, the ifs that I've showed you so far, we've been typing them directly into the cell. Now, that might be your preferred method, but also remember that you can use the functions dialog box if you find that a little bit easier. Now, you can access your functions dialog box simply by clicking on this FX icon and then searching through your functions list for the function that you want. So in this case, if I click go, there it is at the top. Alternatively, I could jump across to the Formulas tab, and in my functions library from the logical group, I could choose if. And that's basically going to open up my arguments, but in a dialog box as opposed to just having them appear underneath the formula in the cell. Now, some people find this method a lot easier, particularly when they're learning more complex formulas. I'm somebody who prefers to just type it into the cell, but I'm going to show you this example using the functions dialog box so you can see the other option that you have. Now, before we get on to doing this, let's just take a look at our data. So here I have a list of furniture sales for 2018 and 2019. We have the products listed in column A, the customer, the date, the item cost, the number of items they purchased, and the total cost. And the total cost is a calculation. It's basically the item cost multiplied by the number of items. And what we need to do here is complete the shipping column and the total column. And I can see over here for orders over $1,500, there's going to be a shipping charge of 2% of the cost. So we need to make sure we incorporate this calculation into our if formula. So let's widen out this column just a little bit so we have more room. And I'm going to click in cell G4. Let's jump up to Formulas, into logical and select if. Now notice as soon as I've done that, it's put the word if into the cell, and now I can perform my logical test. So my logical test in this scenario is if the total cost in cell F4 is greater than 1500. Now, if I'd hard-coded 1500 into here, the formula is still going to work. But this goes back to one of those golden rules I was speaking about earlier. If you do hard-code your numbers into your formulas and then those numbers change, it means you're going to have to go back in, find the formula and edit it, and then copy that formula down for however many rows that you've got. It's much more beneficial, efficient and safer to use a cell reference instead. So that is why instead of typing in 1500, I would in general have the amount listed in a cell so I can simply select the cell. So if this value changes, I only need to update it in one place and all of my formulas will update automatically. Now I am going to copy this formula down, so we need to make sure we lock cell K3 so that it doesn't move, F4. And notice here in this functions dialog box, it's telling me what the result of this logical test is for this first row, which is false. So here the total cost is not over 1500. Now I can specify what I want it to say if this is true. Well, if the total cost is greater than 1500, we need to apply a 2% shipping charge. And that is 2% of the total cost. So we need to perform a calculation here. So if it's true, we want to do the total cost multiplied by 2%, the result that we have in K4. F4 to lock that cell because we're going to copy it down. If it's false, so if it's under 1500, well, there's going to be no shipping charge, so I can simply put a 0 in there. Let's click on OK and double click to copy that formula down. Notice for all of the values which are under 1500, we have no shipping charge, but as soon as we get to one that is over 1500, the shipping charge is 2% of that total cost figure. So now, just to complete this table, we can perform a very simple sum calculation. We just need to add together the total cost and the shipping cost. Control Enter and double click to copy that down. So now if any of this information changes over here, so maybe for orders over 1,000, when I hit Enter, my table's going to update and I've only had to change it in one place. If the percentage changes, so maybe it changes to 5%, I can simply change it here and all of my numbers are going to update. So everything is very efficient. In the previous couple of lessons, we started to explore the usage of if to make logical decisions. And in this lesson, I want to move your knowledge on a little bit and start talking about nested if statements. Now you might be thinking to yourself, what on earth are nested if statements? Well, basically what they are if statements inside other if statements. So let's take a look at an example of what I mean. Now in this table of data, again, we just have some employee data. So we have employee names, location information, department, the date they were hired, the number of years they've been at the company, their salary, and then the job rating. And it's this column here that is going to be important in this particular lesson. Because what we're trying to do here is we're trying to dish out end-of-year bonuses based on that employee's job rating. And notice I have another little table on the right-hand side, which basically sets out the bonus amount assigned to each job rating. So if they have a job rating of 5, which is the best in this case, they're going to get a bonus of $3,000. If their job rating is 4, it's going to be $1,500, 3, 900, 2, 100, and if it's 1 or 0, they're going to get nothing. So what I'm having to do here is basically I need to perform multiple logical tests. Because I want the formula to look at this cell and say, if it's 5, the bonus is this amount. If it's 4, the bonus is this amount. If it's 3, the bonus is this amount, so on and so forth. And this is where nested if statements come in. And I will say these can get quite complicated, but when you break them down, they're actually pretty logical. So let's take a look at how we would construct this. Now, the result that I'm actually looking for in column H is I basically just want it to output the amount of the bonus, so 3,000, 1,500, 900, so on and so forth. I don't want it to say bonus or no bonus at this stage. So we're going to type in equals if and open our bracket. So we want our first logical test. So we're going to say if the job rating in cell G4 is equal to 5, which we have listed in cell J4. Remember, I could have hard-coded this in and typed 5, but we want to try and get away from hard-coding in values and use the cell reference instead. Now I'm going to lock this cell because I don't want it to move. Now, if that is true, they're going to get a bonus of 3,000. So I simply want to select the cell and again, make sure that I lock it, comma. Now, normally at this stage, I would then go and type in the value if false. But I need to add in more logical statements. So I'm going to go straight into my second if. And this is where we get the terminology nested ifs, because you have if statements inside other if statements. And I basically go through this process again. So if the job rating is equal to 4 this time, so J5, lock the cell. If that's true, they're going to get a bonus of 1,500, lock the cell, comma, next if statement. If the job rating is equal to 3, then they're going to get a bonus of 900. If the job rating is equal to 2, then they're going to get a bonus of 100, and then the final if, and then we have our final if the job rating. Now I could put here equal to 1, but if they've got a 0, I also want it to include that. So what I'm going to say is if it's less than or equal to 1, then they're going to get nothing. And then the value if false is going to be 0. Now that is a really long formula, and it's a little bit easier to see in that formula bar. Now when you're constructing formulas like this, remember you need to close off as many brackets or parentheses as you've opened. So I've got quite a few there. If I count them, I think I've got about 4 or 5. So let's just add 4 onto the end here. When I hit enter, if I haven't got enough, which I haven't in this case, Excel is going to automatically correct me. So I'm going to say yes to select the correction. Let's double click to copy this formula down, and I should find that everything in here works. So the job rating of 1 is going to give a result of nothing, which is correct. A job rating of 4, they're going to get 1,500. Job rating of 5, 3,000. Job rating of 2, 100, so on and so forth. Now notice here that I have this little green triangle in the corner. This is denoting that there is some kind of warning or maybe an error on these cells. And what this is basically telling me, if I click this little warning icon, is that I have unprotected formulas. So it's a long formula that I haven't protected. So anyone can go in here and make changes to this formula. Now I'm actually fine with that. So what I'm going to do is Control Shift down to select all of the cells. And I'm going to say ignore error just to get rid of those green triangles. Always worth checking your warnings. Sometimes they are errors that you need to fix. Sometimes they're just kind of notifications letting you know that maybe you haven't included enough data, or maybe in this case, a long formula is unprotected. So that is a nested if statement. We have if statements inside if statements. Now it might be that I want to do this in a slightly different way. So maybe instead of having the actual bonus amounts listed out just here, maybe I just want it to say if they're going to get a bonus or if they're not going to get a bonus. Because basically everybody with a job rating of 2 to 5 is going to get a bonus. It's only those with a job rating of 1 who aren't going to get a bonus. So Control-Shift down, I'm going to delete this formula out and we're going to just reconstruct it in a slightly different way. So we're going to say if our logical test, if the job rating, now this time I'm going to say, is greater than or equal to 2, remember we need to lock that. If that is true, then they're going to get a bonus. If that is false, so if the job rating is less than 2, they're not going to get a bonus. So that formula is a lot shorter to construct. So it really all depends how you want to do these and set this up. Now I will say that with that nested if statement, it is a very long formula. And there is a newer formula that's been released in the later versions of Excel, so from Excel 2016 onwards, called IFs. Not to be confused with nested ifs, we have a formula called IFs. And if I type it into a cell, you can see it sitting just there. Now this is a way to make our nested if statement formulas a little bit shorter. I will say not that much shorter, but a little bit quicker to construct. And that's what we're going to take a look at in the next lesson. In the last lesson, I showed you how you can create a rather long nested if statement in order to perform multiple logical tests. And what we ended up with was a pretty long formula. Now, I did mention that in recent versions of Excel, there's been a new formula added called IFs, which makes constructing nested if statements a little bit more efficient. And I emphasize the word a little bit. It really just means you don't have to keep typing in if each time. You can go straight into the logical statement. So it is a little bit more efficient, but don't be expecting it to drastically decrease the amount of time you spend constructing this formula. So let me show you a couple of different examples. Now we're going to do the same example again, just so you can see how it compares to the nested if statement on familiar data. So if I want to do basically the same thing as what we did in the last lesson and output the bonus based on the job rating, instead of doing all of those if statements, I could use the IFs function. I'm going to press the Tab key to select it from the list. Logical test 1. So we're doing the same thing here. So if the job rating in G4 is equal to 5, F4 to lock that cell, if that is true, we want it to return a bonus of 3,000, F4 to lock the cell. Now, in the old nested if way of doing this, we would then need to go in and start typing in our if statement. Now, with the IFs function, we don't have to do that. We can literally go straight into logical test number 2. So we don't have to type in if, we can simply say if G4 is equal to 4, F4 to lock, then they're going to get a bonus of 1,500. We don't need the if statement again. We can say if G4 is equal to 3, then they're going to get a bonus of 900, so on and so forth. I also don't need a false argument here, so I can literally carry on going through. I'm going to stop there because I think you've got the idea. I simply need to close my bracket. If I do a Control Enter and then copy down. Notice that for the ones that I've set this for, so job rating 5, 4, and 3, I have values in there. Now this time I have NA because I haven't assigned job ratings 1 and 2 to anything. So Excel doesn't know what to do here, so that is why I have an NA error. And towards the end of this section, I'm going to show you how you can deal with things like NA errors in your worksheet and make those more meaningful as well. But hopefully you get the idea as to how IFs works. It's basically the same as doing nested if statements, except you don't need to keep typing if into the formula, and you don't need to provide a false result on the end. Let's take a look at another example of how we can use IFs. Now here we're going to construct a basic IFs formula that's going to return the day of the week when a day number is typed in. So the way that I see this is that Sunday is day number 1, Monday is day 2, Tuesday day 3, so on and so forth. And I want people to be able to come down here and enter in number 4 and have it return the day from this list above here. So we can do this using if-s. So we can say equals if-s. So if the value in this cell, which is currently empty at the moment, is equal to 1. Now I am going to hard code this in here, but as I said, you may want to list 1 to 7 out somewhere in your spreadsheet so you can use that cell reference. But for the time being, let's just leave it on 1. So if the number in A11 is equal to 1, if that's true, I want it to return the result of Sunday, comma. Straight into logical test 2. If the value in A11 is equal to 2, it's going to return a result of Monday. I'm going to carry on going. So if A11 is equal to 3, we're going to get a result of Tuesday. So let's just carry on going through all of these. If A11 is equal to 4, then we're going to get Wednesday. A11 is equal to 5, we're going to get Thursday. If A11 is equal to 6, then we're going to get Friday. And then finally, if A11 is equal to 7, we're going to get Saturday. Close off the if-s and hit enter. Now, currently we have an NA error in here because I don't have anything in cell A11. And this formula consistently refers to that cell looking for a number. But now if I add, let's say 2, it's going to give me my result. Let's add 7 and it changes. If I add something outside of the criteria that I've specified, I'm going to get an NA error. Now it might be again that you want to add in some error checking so that if somebody types in a number outside of 1 to 7, instead of just getting NA, you want it to say to them, please type a number between 1 and 7. And we're going to explore how we would do something like that towards the end of this section when we look at error checking. But those are a couple of different examples of how you can use if-s, and hopefully that illustrates quite nicely the differences between nested ifs and the if-s formula. I recently conducted a poll on LinkedIn where I asked all of my followers and connections to let me know which functions in Excel they find the most useful. And by far the clear winner was COUNTIFs and SUMIFs. And both of these functions, as well as their sister functions, average if, min if, and max if, are effectively if statements which have conditions or have criteria. And there's a really important distinction to make here. In this lesson, we're going to talk about COUNTIF, SUMIF, and average if. In the next lesson, we're going to talk about COUNTIFs, plural, SUMIFs, average ifs. And those latter three are newer additions to Excel. The original functions that we've had for quite a while now are the singular COUNTIF, SUMIF, average if. So let's start out in this lesson by taking a look at how those work, and then we'll add a bit of complexity to it in the next lesson. What we have here is a small table. We have some sales team members. We have the company that they work for. We've just got 2 companies in here. We have their job titles, so they're either a sales rep or a sales manager. And then we have the total amount in dollars that they've sold. Now, what I want to find out is some information, but based on criteria. So if we take a look at this first table and just concentrate on this first one, my criteria is going to be microworld. Because what I want to work out here are the total sales for microworld. So we're adding in a condition where we have to tell the formula, perform a sum calculation of the total sales, but only when the company is equal to microworld. So we only want to add up those total sales. So in this scenario, where we have one piece of criteria, which is microworld, we use the singular form SUMIF. And this is a fairly straightforward calculation to do. So let's type in equals SUMIF. What arguments do we have here? Well, our first argument is range, our second argument is criteria, and then we have a third optional argument. How do I know this is an optional argument? Well, it's enclosed in square brackets. So every time you see an argument that has square brackets around the outside, it means it's not a mandatory piece of criteria. You don't have to include it in order to get this formula to work. Now, we are going to include some range in this calculation, so we're going to use all of the arguments. Now, our first argument here is range, and then we have criteria. Now, I like to work backwards when I'm thinking about this. What is my criteria in this formula? Well, my criteria is microworld. So my range is going to be wherever I'm going to find the word microworld. So I'm going to find that in the company range. So my first argument here is the range, and then I can specify the criteria that I'm looking for. So the criteria I have listed in cell F6. Now again, I could have hard-coded in the word microworld, in quote marks of course. But as I said, wherever possible, try and use cell references. Now the final argument here is that optional argument of sum range. Now in this case, I do need this, because otherwise Excel isn't going to know what I want to add up. I haven't told it to add up the total sales yet. So my sum range is going to be total sales. Close the bracket, hit enter, and there is my result. So let's review. We're saying sum if the company range equals microworld. If it does, sum the total sales. So that is sum if, where we use a single piece of criteria, in this case microworld. Let's take a look at how this would work if we're counting as opposed to summing. So in this second example, again, we have one piece of criteria. I want to work out the total number of employees at Computech. So effectively, I want it to look through this table, and wherever it finds Computech, I want it to count the number of entries, and that's effectively going to give me the number of employees that work there. So for this, we have one piece of criteria, so we're using COUNTIF singular. This time we have two arguments, range and criteria. Again, I like to work backwards. My criteria is going to be Computech. Which range am I going to find that in? I'm going to find it in the company range. Comma, my criteria is Computech, effectively cell F14. Close the bracket, hit enter. It's telling me there are 6 employees at Computech, and because my dataset is reasonably small, I can just do a quick visual check just there, and yes, I do have 6 employees. It's also worth noting that down in the status bar, if you take a look over on the right hand side, it's telling me the count is 6. Now, if you can't see that information, a little quick tip here, if you right click in the status bar, make sure you have average count, numerical count, min, max and sum turned on, so that when you start selecting things in your worksheet, you can see all of those values in the status bar at the bottom. So let's do the final calculation down here. This is just doing an average. So this time I want to find the average sales for Computech. Again, one piece of criteria. So this time we're going to use average if in its singular form. We have 3 arguments just here. My criteria is Computech, so the range is going to be company. The criteria is Computech, and the average range, well, I'm looking for the average of the sales. So I want to use the sales range. Close the bracket, hit enter, and now I get my average. So that is how we can use those 3 super useful formulas to return results based on one piece of criteria. In the next lesson, I'm going to show you how you can do the same thing, but how we can incorporate multiple pieces of criteria. In the previous lesson, I showed you how to construct 3 conditional if formulas, SUMIF, COUNTIF, and average if. And all 3 of those formulas use one piece of criteria. So now what we're going to do is we're going to move our knowledge on a little bit, and I'm going to show you how you can use COUNTIFs, SUMIFs, and average ifs to create formulas that use multiple pieces of criteria. And I will say that these formulas, the plural versions with the S on the end, these are newer formulas in Excel. These were introduced a few years ago, and they've quickly become the favorite formulas of a lot of people simply because they are so useful. Now let's take this first example. The only real difference between SUMIFs and SUMIF is the number of pieces of criteria we're using in the formula. When we use a SUMIF, we can only specify one piece of criteria, whereas if we use SUMIFs, we can specify multiple pieces of criteria. So let's take a look at this second example. What I'm trying to do here is work out the total sales for all sales reps who work at Microworld. So I have two pieces of criteria here, Microworld and sales rep. So because I have two pieces of criteria, I need to use SUMIFs as opposed to SUMIF. Now another difference between this formula and the SUMIF formula is the way that the arguments are organized. In the SUMIF formula, the sum range argument is at the end and you specify your criteria and range first. Whereas when you're using SUMIFs, you're asked to specify the sum range first of all. And I actually find this a lot more logical to understand. So the first thing we need to do here is specify the sum range. So what are we trying to add up? Well, we're trying to add up the total sales. Criteria range 1. What is our first piece of criteria? Well, our first piece of criteria is going to be Microworld. So our first criteria range is going to be wherever we find the word Microworld, which is the company range. Criteria 1 is Microworld, comma. Notice the arguments have now moved on to criteria range 2. So I can now add in my second piece of criteria. So once again, I like to work backwards. What is my second piece of criteria? Well, that is sales rep. Where am I going to find that? I'm going to find it in the job title range. So we're going to select the criteria range and then select the criteria, which is sales rep. I can then close my bracket because I only have two pieces of criteria. And when I hit enter, it's going to give me my result. And again, because I have a fairly small data set here, I could do a quick visual check. Let's look through for Microworld sales reps. So we have one just here. We have another one just here. And that is it. So basically my result should be the total of these two cells. And I can see that yes, that looks to be correct. What about if I have three pieces of criteria? Well, again, we can use SUMIFs. Our sum range is the total sales. What is our first piece of criteria? Well, it's Microworld. We're going to find that in the range company. Our criteria is Microworld. Our second criteria range is going to be the job title because the second piece of criteria is sales rep. And now we have a third criteria range. So we only want to see sales that are greater than $7,000. So criteria range 3 is going to be the total sales range, and our criteria is what we have listed in here. Greater than 7,000. Again, I could have hard-coded that in by typing in greater than 7,000, but if that changes, it makes it a lot more difficult. So I'm going to stick with the cell reference. Close the bracket, hit enter, and there I get my total. And I could carry on going. If I had 6 pieces of criteria, I could use SUMIFs for that as well. And this works pretty much the same when you're using COUNTIFs. For this example, we have 2 pieces of criteria. I'm looking to find the total number of employees at Computech with the job title Sales Manager. So for this, we can use COUNTIFs this time. Criteria range 1. Well, our first piece of criteria is Computech. We're going to find that in this range just here. And our criteria is Computech. Our second criteria range is going to be the job title range because our second piece of criteria is Sales Manager. Close the bracket, hit enter, and there we go. Let's do the final one because practice does make perfect. Criteria range 1 is the company. Our criteria is COMPUTEC. Criteria range 2 is the job title, and our criteria is Sales Manager. Criteria 3 is less than 9,000, so we're going to select total sales, and less than 9,000 is our criteria range. Close the bracket, hit enter, and I get my result. Hopefully you're getting the idea, but let's just finish this off by doing the average. So we're going to say average ifs. Our average range is going to be our total sales. That's what we want to find the average of. Criteria range 1 is going to be the company, and the criteria is COMPUTEC. Criteria range 2 is the job title, and the criteria is Sales Rep. Close the bracket, hit enter, and there I get my average. Now it's worth noting that we have these formulas for min and max as well. So if I just show you a quick example, we do have a min ifs that we could use if I wanted to find the minimum value in a range. So if I wanted to find the minimum sale, I could choose the total sales as my minimum range. My criteria might be the minimum sales for COMPUTEC. So my criteria range would be the company. Criteria 1, let's just grab COMPUTEC from over here. I could carry on going if I had more pieces of criteria, but effectively I would do exactly the same thing. It's going to give me the minimum amount of sales for COMPUTEC. I just want to finish off this section on logical functions and if statements by talking a little bit about how you can use ifs to handle errors in your spreadsheets. Now, if we take a look at this example just here, we're fairly familiar with this data. This is that bonus spreadsheet we were looking at previously. Now, in this bonus column, if we take a look at the first formula, I've basically set up a formula to work out the bonus only for people who have a job rating of 5 or 4. And so you can see that reflected in this column. So where they have a job rating of 4 or 5, we have the bonus amount. Anything under 4, so 1, 2 or 3, we have an NA error in the cell. And that's because I haven't accounted for job ratings 1, 2 and 3 in this particular formula. Now, it might be that you are happy to leave your spreadsheet looking like this, but what I will say is that if you do have a spreadsheet that has lots of errors contained within cells, even if those errors are correctly there, which they are in this case, it makes your spreadsheet not only look a little bit messy. If you were to send this to somebody else who's maybe not familiar with the data, they might think that these are actual errors that need to be fixed. What would be much better here would be to add some meaning to these NA errors. So maybe instead of NA, I wanted to say no bonus, which makes it a lot clearer. Now we can do this by using error handling formulas. And if we jump up to the Formulas tab in this logical group, you're going to find the two that we're going to use in this lesson in here. We're going to take a look at if error and if NA. Now let's start out with if NA. Now what if NA will do is it will help you deal with any NA errors that you have in your spreadsheet. Now NA isn't the only type of error that you might see in cells. You might see a div error or a value error or a name error. And all of these different errors mean different things. But if you specifically have an NA error in a cell, you can use the if NA function to assign meaning to that. Now, as we do have an NA error, we're going to use that function. Now, what I want to do here is let's select the first cell that contains a formula. Let's jump up and edit this in the formula bar. Now, what we're going to do is we're going to type in if NA. That's the formula we're going to use. Now notice underneath this particular function has two arguments, value and value if NA. So in other words, value if we find an NA in the cell. Now the first argument, the value, well the value in this cell is generated by that ifs formula. So effectively the ifs formula is our first argument, it is our value. So we can click on the end, press comma, and now all we need to do is simply specify what we want to say in the cell if it comes across an NA error. Well, I wanted to say no bonus. We need to add this in quote marks and close the bracket. So we've wrapped an if NA formula around our IFS formula. Hit enter and take a look at that. Now, if I copy this down, I've replaced all of those NA errors with something that is a lot more meaningful, a text string that says no bonus. Now, the if NA formula can only be used when you have NA errors in your spreadsheet. And as I said, there are lots of different types of errors that you can get in a cell. And for any other error, you can't use if NA to assign any meaning. That is where we would use the second error handling formula, if error. If error works in a very similar way to if NA, but it will handle all types of errors, not just NA errors. So let's take a look at this in action as well. Now, if we jump across to the if error spreadsheet, if you recall, we put together a little formula here, and again it's an IFS formula, which gave us the day of the week when we enter in a day number. And what I said was that if somebody enters a day that isn't 1 to 7, so for example 8, it's going to produce an error because the formula doesn't account for that. Now in this case I am getting an NA error again, so I could effectively use the if NA error handling. But we're going to do this in a different way, and we're going to use if error instead. So if error we can use for any type of error, and we edit the formula in exactly the same way. So we're going to type in if error at the beginning. We have the same two arguments, value and value if error. The value again is going to be generated by our IFS formula, so we can go right to the end, press comma, and then we can enter in what we want it to say. Now in this case I wanted to say, please enter a number between 1 and 7. So what I'm doing here is basically giving the user a little bit of guidance if they enter an incorrect value. So let's hit enter, and there we have that piece of text. And if I choose a different day, it doesn't come up. But if I put in day number 10, I'm going to get that piece of text. So using error handling in this way can really help you keep your spreadsheets consistent, meaningful, and easy to understand for anybody who might be using them. The only takeaways here are if you have NA errors in the cell, you can use if NA or if error. If you have any other type of error, you can only use if error. It's time now to do exercise 1. And in this exercise, we're going to practice some of the skills that we've learned in this section on logical functions. So in the first part of this exercise, I'd like you to use either nested ifs or the IFs function and complete the prize money field in the table. And you'll notice on the right we have a smaller table which contains the information that we're looking for. And remember, if you're going to copy this formula down, then you need to make sure that you're locking those cell references in place. In the second part of this exercise, we have a similar table, but this time I'd like you to practice using COUNTIF, SUMIF, COUNTIFs, and SUMIFs. And I want you to use those formulas and complete the results in column H. So it's time to pause this video and give that a go. If you'd like to see the answer, then please keep watching. So in this exercise, we need to use nested ifs or the IFs function to work out the prize money. So I'm going to use IFs to do this. So we want our first logical test. Well, our logical test is if the medal is equal to bronze, F4 to lock that cell reference. If that's true, then they're going to get $100 in prize money, F4 to lock, comma. Because I'm using IFs, I can go straight into logical test number 2. If the value in cell D4 is equal to silver, then they're going to get $250 in prize money. And the last logical test is if the value in D4 is equal to gold, then they're going to get $500 in prize money. Close off the bracket, hit enter, and now we can copy this down. And if we do a quick spot check, let's take a look. Every time we have gold, we have 500, bronze, we have 100, and silver, we have 250. Let's take a look at the second part of the exercise. Well, here we need to use COUNTIFs and SUMIFs. So in the first table here, we need to find the number of athletes from the USA. Now we only have one piece of criteria, so for this I'm going to use COUNTIF. My criteria is going to be USA. Where am I going to find that? I'm going to find it in the country column, Control-Shift-Down arrow. I'm going to work on this up in the formula bar. And my criteria, because I don't have it contained within a cell, I'm going to need to type that in. So let's put USA in quote marks, close the bracket and hit enter. The next one, we have two pieces of criteria, so we need to use COUNTIFs. So our first piece of criteria is going to be that the athlete is from Australia, so our criteria range number 1 is going to be the country column, Control-Shift-Down arrow. Let's work on this up in the formula bar. Our first piece of criteria is Australia. Criteria range 2, well, our second piece of criteria is female. So our criteria range is going to be the gender column, comma, and our criteria is going to be F. Close the bracket, hit enter, and there I get my result. And finally, we have 3 pieces of criteria here, so COUNTIFs again. We're looking for athletes from the UK who are male who achieved a silver medal, so 3 pieces of criteria. Our first criteria range is the country, Control-Shift-Down arrow. Up in the formula bar once again. And criteria number 1 is UK. Criteria range 2 is the gender, so let's select that, Control-Shift-Down arrow. And our criteria this time is male. And our third criteria range is the colour of their medal, so let's select that. And this time we are looking for silver medals. Close the bracket, hit enter, and there we get the result. And finally, I asked you to work out the total prize money for various different pieces of criteria. So for this, we're going to use the SUMIF function. For the first one, we just need SUMIF because we only have one piece of criteria. Our criteria is the USA, so our range is going to be the country, Control-Shift-Down arrow. And then we need to put our criteria in quote marks. And then our sum range is going to be the prize money, Control-Shift-Down arrow, close that bracket and hit enter. Now we need to do SUMIFs because we have multiple pieces of criteria. This time we have the sum range first of all, so we're going to sum the prize money once again. Criteria range 1 is going to be the gender, and the gender we're looking for this time is female. And then our final piece of criteria is that we're looking for Canadian athletes only. So we want our criteria range to be the country, and our criteria is going to be Canada. Now the final one was a little bit unfair of me really, because I didn't actually show you this in the lesson. But I wanted to show you this in the exercise just so you can see something else that you can do with SUMIFs. Now for this one, we want to total the prize money for North America. So that's going to be the USA and Canada. So we have 2 pieces of criteria that are coming from the same column. So how would we do this? Well, if you worked this out, well done. It's not too hard to work out, but what we need to do here is basically perform 2 SUMIF calculations. So let's start out with our SUMIF. We want our range. So our criteria is going to be USA, first of all. So our range is going to be the country range. And our criteria is going to be USA. And we want to specify our sum range, which is going to be the prize money. Now what we need to do here is close off the bracket and then say that we want to plus and then go straight into the next SUMIF. So again, our range is going to be the country, but this time the criteria is Canada. And then finally the sum range is the prize money, and close the bracket. So we're just doing two SUMIFs and we're adding them together so that we can get the total for two pieces of criteria that are coming from the same column. Let's hit enter, and there is our answer. So hopefully you got most of those. I wouldn't expect you to get the last one, but if you did, very well done. I will see you in the next section. In this lesson, we're going to learn how to look up information using some of the best loved functions in Excel, and those would be lookup functions. And probably the most well-known lookup function is VLOOKUP. And VLOOKUP is one of those functions that you'll always see at the top of the list when it comes to most useful functions or functions that everybody should know. And that's because you can use VLOOKUP in so many different scenarios. Now, when it comes to using VLOOKUP, there are two different ways that you can use it. You can do an exact match or you can do an approximate match. And in this lesson, we're going to start out by taking a look at the more common of those two, which is VLOOKUP exact match. Now, before we get on to how you construct a VLOOKUP, let's first make sure that we all understand what exactly a VLOOKUP is and how it can be useful. So I've just got a little example of a VLOOKUP on this page. So I have a small data table which contains some order numbers, the items that these order numbers relate to, and then the price of those items. And what I've done over here is I've constructed a little data validation drop-down list for all of the different order numbers. And what I can do here is select an order number from this list, and it's going to return the item and the price. And if I click on any of these cells just here, notice in the formula bar, I'm actually using a VLOOKUP. Now, what this formula is actually doing is it's basically saying, look up whatever value we have in cell G3, look it up in this table over here, and then return the information from column number 2. And then the VLOOKUP underneath is basically doing exactly the same thing, but it's saying instead return the information in column number 3. So that is how VLOOKUP works. Now, a couple of really important points when you're working with VLOOKUP. What you're using as your lookup value, so for us in this example, that is the value in cell G3, it has to exist in the table of data. Because without the lookup value, Excel doesn't know which of these results it needs to return. So that is basically how a VLOOKUP works. So now let's look at how we construct it using a different example. Now, if we jump across to the next worksheet, you can see that I have on here just a few different part numbers, and currently the description and the unit price columns are blank. And then on the third worksheet, I have a parts catalogue. And this contains the part numbers in column A, the descriptions in column B, and the price in column C. So basically what I want to do here is I want to use the part number as the lookup value because this is the column that is common between these two tables. I want to look up the part number in the parts catalogue, and then I want to return either the description or the price depending on which one I'm doing. So let's construct our VLOOKUP. Now, the first thing that we want to return here is the description for part number 19232. So I'm going to type in equals VLOOKUP. Let's take a look at our arguments. The first argument here is the lookup value. So that's the piece of information that is common between the two tables. So for us, the part number is our lookup value. We then need to specify where we're looking up this part number. So what is the table array? Now, it might be that you have your table on the same spreadsheet, and that is fine. You can just select it. If I jump across to Parts Catalog, I can select this entire table, and that is my table array. Now, I'm going to go to the formula bar to continue my editing, and notice what I have in that formula bar now. Because my table is on a different worksheet, it's put in the worksheet name, Parts Catalog, and then the cell range. I now need to specify the column index number, and that is basically the column of information that we want to return. Now, we're looking up the description first of all, and this is a really important point about VLOOKUP. When it comes to the column index number, VLOOKUP numbers columns in the table from left to right. So part number would be column 1, description column 2, and price column 3. So if we want to return the description, we're returning column number 2. And our final argument, which is an optional argument because it's in brackets, is a true or false argument. And what we select here determines if we're doing an approximate match or an exact match. Now we're going to do an exact match because we exactly want to match the part number in the table. So we can have a false argument on the end here, or alternatively we could just put 0. That would also do an exact match. Or, because this is an optional argument, I don't even need to have that on the end because the default behavior for VLOOKUP is to do an exact match. So I'm going to leave it off. Let's hit enter, and it brings back that description information. Now I'm going to widen out this column a little bit, and I think I'm going to wrap this text around just so it doesn't take up so much room. Let's do the same thing, but let's do it for unit price instead. So we're basically going to construct the VLOOKUP in exactly the same way. It's just the column that we're returning that is different. So this time we want to return column number 3. So equals VLOOKUP. Our lookup value is still the part number. Our table array is our parts catalogue, and I'm going to show you a simpler way of doing this in a moment. Let's select the entire table and go up to continue editing in the formula bar. The column index number, well, we want to return the information from column 3, and we're exactly matching that part number, so we can have false, 0, or nothing on the end there. Hit enter, and there we get that unit price. Now you might want to do a little bit of messing around with the formatting of this cell, but that is basically how VLOOKUP works. Now, if I was to try and copy these formulas down, they're actually not going to work correctly because I haven't locked the cell range. So I know it looks like they're working fine. It's actually returning the wrong results down here from the table because I didn't lock the cell references. So as I drag down, this entire table is moving down as well. So a way that I like to do this, I find this a lot easier, is if I'm doing a VLOOKUP, in general, I will make my table of data a named range. So let me just very quickly do these again and show you how that works. So I'm going to go to my parts catalog, Control A to select everything, and in the name box, I'm going to call this parts underscore catalog. Now by naming this range, it makes your VLOOKUP a lot easier to construct. So let's go to VLOOKUP. Our lookup value is the part number. Our table array. Well, this time I don't need to jump across to the other worksheet and select that range. I can simply press the F3 key on my keyboard and it's going to bring up all the named ranges that I have in this workbook. There is mine, parts catalog. Let's select it. And the cool thing about this is that when you create a named range, it's basically very similar to locking the cell, so they're never going to move. Column index number is 2, and we're doing an exact match. Close the bracket, Control Enter, and then I can double click to copy down and my results are correct. Let's just do this again for the unit price. Lookup value is part number. F3 to pull up my named ranges. Let's select the parts catalog. The column we're pulling back this time is column number 3, and we want to do a false argument on the end, or a 0, or absolutely nothing. It's all good. Double click to copy down. Now, one thing to note here is take a look at this part number. I have NA errors in these cells. Now, I'm going to hazard a guess that I've got these errors because this part number doesn't exist in the catalogue. So if I want to do a quick check, I can jump across to my parts catalogue. I'm going to do a Control F for find, and I'm going to try and find that part number, 1, 2, 3, 4, 5. Find next. It can't find it. So that is why I'm getting that NA error. Now, as we saw in the previous lesson when we were talking about error checking, I might want to tidy these errors up a little bit by adding in some error handling. So let's click on that first formula up in the formula bar, this is an NA error, so I'm going to use the if NA function. The value is going to be generated by the VLOOKUP, and I'm going to make this a bit more meaningful by just adding on to the end here, part not found. So anyone looking at this spreadsheet is going to know that that is the reason why we don't have a description and unit price. Let's do the same for this one. Up to the formula bar, if NA, click at the end, and this time I'm going to say price not found. Close the bracket, Control Enter, and then I can double click to copy down, and now this table doesn't look like it includes errors. We've added some meaning. So that is how you do a VLOOKUP using that exact match option, that false argument on the end. In the next lesson, I'm going to show you another example, but this time we're going to be doing an approximate match using the true argument on the end. In the previous lesson, we saw how we can use VLOOKUP with the exact match false argument on the end to return results. So in this lesson, we're going to look at the true argument, the approximate matching option. So what is the difference between these two? Well, you would use approximate matching for your VLOOKUP if your lookup value doesn't exist exactly in the table. So what do I mean by that? Well, if we take a look at the data that we have on this worksheet, in this first table, I have effectively some salary bands. And this is showing me the low end and the high end of this band, and then the tax rate that applies to each of those bands. And what I want to do in the second table is I want to look up the salary and I want it to return the marginal tax rate for that salary. Now, if we take a look at the first one here, 55,000. Does 55,000 exist exactly in this table over here? Well, if I take a look at my values, I can see, no, I don't have exactly the value 55,000 listed here. This annual salary falls in this bracket just here. So if I was to do an exact match, it's not going to find it because the exact match argument, that false argument, exactly matches the lookup value in the table. So for this, I'm going to need to use the approximate matching option, which is the true argument on the end. Now I'm going to do exactly what I did in the last lesson, and I'm going to create a named range for my table simply to make this whole process a lot easier. So let's select the table. In the name box, we're going to say tax underscore rate and hit enter. So now I can construct my VLOOKUP. So we're going to type in equals VLOOKUP. My lookup value is going to be the annual salary. The table array, well, I can press the F3 key and there is tax rate. Click on OK. The column index number, so what do I want to return here? Well, I'm looking for the tax rate, which is column number 3. And this time we want to do an approximate match. So we want the true argument on the end, or alternatively, we could just type a 1. Let's close the bracket and hit enter. And if I just double check this table, I can see that yes, 55,000 falls in this range just here, and the tax rate is 25%. Let's do that one more time just to practice. VLOOKUP. Lookup value is cell E6. Table array, we can press F3. Alternatively, you can just start to type in your named range and it will appear in the list underneath. Double click to select, comma. We want the third column and we're doing an approximate match. 1 on the end this time. Close the bracket, hit enter, and let's double check to make sure this is correct. This salary falls in this bracket up here and the marginal tax rate is 10%. And just to show you how you can do this using the functions dialog box, if that is your preferred method, let's click on the FX button. I'm going to search for VLOOKUP. Let's click go. There it is. Double click to select. And now we can complete our arguments in this way. So the lookup value for the final one is cell E7. Table array, I can press the F3 key and select tax rate. column index number is 3, and the range lookup is true, or a 1 on the end there. Let's click on OK to complete that final one. And if I double check this, well, 90,000 is going to fall in this range here, and that has a tax rate of 28%. So that is really the only difference between VLOOKUP exact and VLOOKUP approximate. It all relates to the lookup value and whether that lookup value exists exactly in the table or if it doesn't. Both of the VLOOKUP formulas that we've looked at so far in this section have been using data that runs vertically down the page, hence why it's called VLOOKUP. So in this lesson, I want to show you an example of HLOOKUP where our data is running horizontally across the page instead. Now, what do I mean by that? Well, on this worksheet, I have an example of data that runs vertically down the page. We have our column headings at the top and then our rows of data underneath. And this is by far the most common way to display data. A less common way is to have your column headings in the rows as opposed to in the columns so that your data runs horizontally across the page. And whilst this is definitely not as common, you need to be able to have the tools to be able to deal with that scenario and still perform your lookups. So what we're going to do first of all is we're going to grab this data and we're going to flip it the other way around. And this is also a good opportunity for me to show you a little command you can use if you need to switch data around for any specific reason. So I'm going to click in my data table, Control A to select everything, Control C to copy, and then I'm going to go across to my HLOOKUP worksheet and I'm going to paste this data onto the worksheet, but we're going to paste it running horizontally as opposed to vertically. So what we can do here is on the Home tab, up to Paste, click the lower half and go to Paste Special. And if we choose the Transpose command, that will basically flip your data around the other way. When I click on OK, you can see what that's done. I now have my column headings in the rows and my data runs horizontally across the page. And if I zoom out a little bit, because I do want to do a little bit of resizing so we don't have those hash symbols in some of the cells. Let's double click to resize all of those and then zoom back out again. Perfect. Now, as I said, this is by far not my favorite way of displaying data. It really does look quite messy, but you will come across data sets throughout your Excel career, which will be structured in this way. So if we have our data this way round, how can we do a lookup? Well, the simple answer is pretty much in exactly the same way, just using the HLOOKUP function as opposed to VLOOKUP. So what I want to do up here is I want to be able to type in a movie name. So let's just start with La La Land. And I want it to return the year, what it's rated, and the genre. So the first thing I'm going to do is I'm going to create a named range for my data set down here. Control A to select all, up to that name box, and we're going to say movie list and hit enter. So now if I want to return the year, I'm going to use HLOOKUP. We have exactly the same arguments. There is one minor difference in here, which I'll speak about more when we get to it. First argument is the lookup value. Well, we want to look up the film, so B5. Table array, where are we looking it up? Well, we've created a named range. I can press F3 and select my movie list. This time it's asking for a row index number as opposed to a column index number. So instead of counting across columns from left to right, we simply need to count down rows until we get to the one that we want to return. So we want to return the year in this example, and that is row number 2. And then we get to use our approximate or exact match. Well, I want to exactly match the movie name in the table, so we're going to have a false argument on the end here. Close the bracket and hit enter, and it's telling me that La La Land was released in 2016, and I can see that yes, it was. Let's do it again. So equals HLOOKUP, lookup value is the movie, F3 to select our table array, row number this time is row number 3 because we want to return what it's rated. And we're doing an exact match. So I'm going to put a 0 on the end here. Close the bracket, hit enter, and there we go. Let's complete this set. This time I'm going to use the functions dialog box and we're going to search for HLOOKUP. There it is. Double click to open. Lookup value, movie name, table array. Let's press F3. Select our movie list. Row index number. Well, this time we're looking for the genre. So that is row number 1, 2, 3, 4, 5, row number 6. And our range lookup, we're doing an exact match, so it's a false. Let's click on OK, and there we go. And if I was to change this film name, so let's type in Jackie, I should find that all of these results update. Let's check our table. There is Jackie. Everything is looking good. So that's really the only difference between VLOOKUP and HLOOKUP. It's all about how your data is structured and whether you have those column headings in the rows or the columns. Whilst VLOOKUP is an amazing function to know to perform powerful lookups, after you've been using it for a while, you're going to start to come across some of its limitations. So in this lesson, I want to just briefly talk about the limitations of VLOOKUP and then show you a better, more flexible way of performing lookups. So let's just review. Now, when it comes to VLOOKUP, if we take a look at this first example that we were using, we're looking up the part number in the parts catalogue and we're returning either the description or the price. And the way that we construct the VLOOKUP is we say look up the part number and then return me either column 2 or column 3. Now the big limitation with VLOOKUP is that your lookup value must always be to the left of what it is that you're looking up, because we can't count back columns. For example, I couldn't use the price to look up the part number using VLOOKUP, because when it comes to the part of the formula where we have to enter in a column number, I can't say count back -2 columns to get the part number. It always has to be a positive going from left to right. So the biggest limitation here when using VLOOKUP is that your lookup value either has to be in the first column or to the left of whatever it is that you want to return. Now that might be absolutely fine in 90% of scenarios that you're going to come across. But you're definitely going to come across some situations where you're going to need a more powerful and flexible way to perform lookups. And that is where index and match come in. So let's take a look at these two functions. Now, index and match are two separate functions in their own right, but you often hear them used together in the same sentence because they are used together so often to perform complex and powerful lookups. And the beauty with using index and match to perform your lookup as opposed to something like VLOOKUP is that it doesn't matter where your lookup value is in the table and what column you want to return, it's always going to work. So let's take a look at this example first of all. I have a table over here which shows me some categories, some apps, the revenue those apps have generated, and the profit. And what I want to do is be able to select an app from this drop-down list and have it return the category, the profit, and the revenue for that app. Now I'm going to be using the app as the lookup value in this table. Now the app is in column number 2. So when it comes to returning the category, I'm effectively having to look up a column going from right to left. So this is a perfect example of where VLOOKUP wouldn't work because we can't have the lookup value in column 2 and return a result from column 1. So we need a better way of doing this. Now, before we actually combine index and match together to perform this lookup, I want to show you what each one does in its own right, which will help you understand why they work so well when used together. So I'm going to click in cell H6 and let's take a look at what index does first of all. Now index has a couple of different sets of arguments that you can use here. And I would say that the first group of arguments is the one that you're going to use most of the time. Now the first argument here is array. Now, the way that I like to remember this is, what is it that I'm looking to return here? I'm looking to return the category. So my array is going to be the category. And an array is effectively another word for range. So our first argument is going to be the category range, the category array, comma. I now need to provide the row number of the item I want to return. Now I want to return the category for the application OneDrive. So if I take a look at my table and find OneDrive, it's just here. What is the row number? Well, if we start at the top, 1, 2, 3, 4, 5, 6, it's row number 7. So if I type row 7 in here, close my bracket and hit enter, it's going to pull back the category of productivity. And if I take a look at that, I can see that yes, that is correct. Now I know exactly what you're thinking at this stage. You're probably thinking, well, that's a bit tedious, having to manually count down to find the row number. And you would be correct. We have a very small data set here, so it's not too much of a bother for me to count down. But what if I had a data set that had hundreds or thousands of rows? I'm really not going to want to spend time counting down the rows to find the value that I need. So we need to find a way of automating the finding of this row number. So with that in mind, let's take a look at what the match function does on its own. We're going to type in equals match. Now for this one, we have 3 arguments. The last argument is an optional argument. The first argument is lookup value. Well, our lookup value is OneDrive. What is the lookup array? So where will we find the value OneDrive? Which range? Well, we're going to find it in the app range. So that is our lookup array. Do we want to do an exact match here? Yes, we do. I want to exactly match the word OneDrive in the table. So I want a 0 argument on the end. Let's close the bracket and hit enter. And take a look at that. It returns the row number that OneDrive sits in. So the match function will do what we need it to do. It's going to automate the finding of the row number. So now we know what each of those functions do. We can combine them together to perform this lookup. So let's start from the top. We're going to type in index. What is our array? Well, our array is what we're looking to return, the category, comma. Now we need to provide the row number. So this is where we're going to use our match function. So we're going to go straight into match. Our lookup value is OneDrive, cell H5. Where are we going to find that? Well, it exists in the app range. So this is our lookup array. And we want to do an exact match of the word OneDrive in the table. We need to close off our match, close off our index, hit enter, and now we get our category. And I should find that if I change this to something else, that's the same category, let's choose something else, it's going to work correctly. Let's do it again. Equals index. What is our array? Well, this time we're looking to return the profit, so this is our array just here. Row number, well, we want to use match to automate that for us. The lookup value is H5. We're going to find that value in the apps list, that is our lookup array, and we want to exactly match the word Instagram. So we want a 0 on the end there. Close off our match, close off our index, and hit enter. Let's double check. So let's find Instagram in this list. Yes, it is in the category social media, and the profit is 786.80. Now we're going to do this again for the revenue. I'm going to do this in a slightly different way so you can see a couple of other techniques. Now, what I'm going to do here is I'm going to take a look at my data and I'm going to create named ranges for each of these columns. And then I can use those named ranges in my formula. Now, a quick way to do this is to select everything in the table up to the Formulas tab, and then in the Defined Names group, I'm going to say Create from Selection. And I want to use the top row as the names for my ranges. Let's click on OK. So now what I should find if I click the name box drop down is that I have 4 different named ranges here, and they've all been named according to the column heading. If I select category from here, that is the range that it refers to. If I select revenue, that is the range. Now you don't have to do this, I'm just showing you a different way that you could construct this formula. I could then say index. This time I'm looking up the revenue, so instead of selecting this range of cells, I could use the named range. So we can type it in, or we can press the F3 key and select it from here. We're then straight into our match to find that row number. Lookup value is whatever we have in cell H5. Our lookup array, where are we going to find this? Well, we're going to find it in the apps list. Now, because I also have this as a named range, I can press F3 again and choose app. And I want to exactly match the name Instagram in the table. So we've got a 0 on the end. So let's just take a moment to review what we have there, because we've used 2 named ranges in this formula. And the reason why I like to use named ranges is because it does make it a lot easier, particularly if you have a much larger data set than I have here, because it means you're not having to keep selecting cell ranges, you can just use the name. But it also makes formulas a lot easier for anybody who's looking at this spreadsheet to understand. Now I need to add another bracket on the end here, hit enter, and there I get my result. Let's check to make sure this is working. Let's choose something else. Twitter, let's double check in the table, that is in the social media category. Revenue is 17,760 and profit is 800. Now that I've shown you how you can combine the index and match functions to perform a powerful, complex lookup, we're going to see how we can do exactly the same thing in a different way. And when I say in a different way, I mean using 2 brand new functions in Excel 2021, and that is XLookup and XMatch. Now, as I said, these 2 functions are brand new to Excel 2021. And XLookup is really another way of performing a lookup very similar to index and match. So it has all of the same flexibility that we love about index and match, but it's a lot easier to construct. So let's use the same examples, but this time, instead of index and match, we're going to use XLookup. So let's click in our cell. I'm going to type in equals XLookup. Now, the first difference you'll notice here is that we do have a lot more arguments. And it's only the first 3 that are mandatory. All of the others, the last 3, are all optional arguments. Now, we're going to go through all of them just so you can see exactly what they do. But if you just wanted to do a basic lookup, you could just use the first 3 arguments. So the first argument is lookup value. So our lookup value is going to be whatever we have in cell H5, comma. What is our lookup array? So where are we going to find Google Docs? Well, we're going to find it in the apps list. So this is our lookup array. And then we simply need to specify the return array. So what do we want to return? We want to return the category. So all we need to do is select the return array. That is basically it. I could close off my formula, hit enter, and I'm going to get my answer. Now, how much easier is that than doing the same thing using index and match? Now, let's double click to go back into this formula, because I did say I wanted to run through all of these arguments. So the next argument is if not found. So we have some additional things we can specify here. So if the lookup value is not found in the table, we can choose to return a value that we specify. So that might be a piece of text. Remember, text needs to go in quote marks. So I might just want to say here, not found, comma. I can choose what type of match I'm doing. Do I want to do an exact match? Do I want to do an exact match or next smaller item or next larger item? Well, I'm going to do an exact match. I want it to exactly match Google Docs. And then the final optional argument that we have here is the search mode. So with this particular argument, we can choose which way or how we're searching through this table. So I can choose to search from first to last or last to first. Now, if I do first to last, let's type 1 as our final argument, it's going to return the result of productivity. Now, we're going to do XLOOKUP again to return the profit and the revenue, but we're going to do this in a slightly different way again. Now, so far we've seen how we can create named ranges and use those in our formulas, but what about if I want to put this data in an Excel table? Well, what I'm going to do is click in my data and press Ctrl T. Yes, my table has headers. Let's click on OK. Now, I don't particularly like this formatting, so let's change that. That looks a little bit better. And I'm going to give my table a name. So let's call this apps_list and hit enter. So now what I could do when I'm constructing this XLOOKUP, let's do it again. So XLOOKUP. Our lookup value is what we have in cell H5. My lookup array is a table this time. Now I've called my table apps list, so I'm just going to start to type it, double click to select that table. Now it's selected the entire table, but my lookup array is just the app column. So what I can do here is press the square bracket and it's going to show me all of the different columns of that table. So I can then go through and just select the app column. Press the tab key to select it and close that bracket. So now I've isolated that column. Comma, what is my return array? Well, my return array this time, I want to return the profit. So again, I could use my table columns. Let's choose the table, square bracket, and I want to choose the profit column this time. Tab key to select and close that square bracket. Now, if I want to essentially skip over an argument, so I don't particularly want to have any if not found text, I can just press 2 commas to move on to the next argument. I want to do an exact match and I want to search first to last. Close the bracket, hit enter, and it's going to return my result. Let's double check to make sure that this is correct. So let's find Google Docs, and I can see that yes, the profit is 1166. Now for our final XLOOKUP just here, I want to focus in on that search mode, so which way we're searching through our data. So let's do our XLOOKUP one more time. Our lookup value is H5. Our lookup array, well, I'm going to use my table range again. I'm looking up the app in the app column. The return array this time is going to be the revenue. So let's select our table and the column. I'm not going to put in any if not found text. Let's press another comma to go on to the next argument. I want to do an exact match and I'm going to search first to last. Close the bracket, hit enter, and I get my result. Now with that search mode, searching first to last, that works perfectly fine for the data that I'm using. But what if I have Google Docs listed twice in this table? So what I'm going to do is on the bottom here, I'm just going to add another row for Google Docs, and we're going to assign it to a different category. So let's say utility. It's going to be Google Docs again, and let's just give it a value of 50,000 with a profit of, let's say, 5,000. Now I'm just going to expand my table out to accommodate that new data. So now effectively I have Google Docs listed twice in this apps list. Now currently, if we use the revenue as an example, it's showing me the revenue of the first Google Docs that it finds in this list because I chose to search from first to last. But if we double click to edit this formula, what I could do is I could change this to something different. So let's do search last to first, -1, and hit enter, and we get a completely different result. This time it's searching from the bottom upwards, and the first Google Docs entry it comes to is this one just here. So it's returning a result of 50,000 for the revenue. So that's how that search mode option works. But as I said, in its most basic form, if you don't want to use all of those optional arguments, you just have 3 arguments: lookup value, lookup array, and return array. Super simple. So now we know what XLOOKUP does. What does XMatch do? Well, XMatch is fairly similar in many ways. We have a lot more arguments than we do when we're using just the basic match. So what I could do up here is if I want to go back to using index and match, I could do an index with an XMatch instead. Our array is the category, so let's select it. And notice that because I have this data in a table, it's automatically going to put the table name and the column name in for me. Row number. Now, if you recall previously, we were using the match function to automate the finding of that row number. But what I could do is use the new XMatch function instead. Again, the last two arguments here are optional arguments. Now, my lookup value is what we have in H5. My lookup array is where I'm going to find that, so that's in this apps list. I can then choose a match mode, so I want to do an exact match, and then I also get that search mode option when using XMatch as well. So I can choose if I want to search from first to last, last to first, or start doing a binary search and sorting in ascending order. So let's do last to first again, -1. Close the bracket, hit enter. I can see that I've forgotten to add an additional bracket on the end, so I'm going to accept the correction. And it pulls back the category of utility because it's finding this entry first because it's searching last to first. Now you can also use XMatch on its own when not combined with index, and it works very similar to the match function on its own. It's basically going to tell you what the row number is. So the arguments are pretty similar. Lookup value. Lookup array is where we're going to find that, which is just here. My match mode is exact, and I'm going to search. Let's do first to last this time. Close the bracket, hit enter, and it's going to tell me what row Google Docs resides in from the top. So pretty much the same results that you get with match, but it's just a little bit more flexible. You have a few more options in there. So that is your introduction to two brand new functions in Excel 2021. In this lesson, we're going to explore how the offset function works. And offset is a function that you'll see quite often used on its own, but a lot of the time you'll see it combined with other functions to produce some really powerful results. So what exactly is the offset function and how does it work? Well, we're going to take a look at a basic example first of all, and then I'm going to show you a more practical way of using offset. Now, the data that we're using in this first example is just some basic sales data for different regions across different months. And what the offset function will basically allow you to do is return a result from a cell that is a specified number of rows or columns away from your starting cell. Now, that is really hard to picture without seeing an example. So let's just click somewhere over here and type in equals offset. Now notice here that we have 5 arguments, and the last 2 are optional arguments because they're in those square brackets. Now the first piece of information, this is the most important piece of information when you're using the offset function, is the reference. You always need to have a starting point, a starting cell, and that cell is used as your reference point. Now, which cell you choose to use as a reference is entirely up to you. But for the purpose of this example, I'm going to use cell A3, comma. The next argument is rows. So what I can say here is I can get this function to move down whatever number of rows I specify. So if I want to, for example, let's say if I want to return the result for the North region for March, I need to move down 3 rows, comma, and I need to go across 1 column, comma. I can then choose the height and the width of my range. So for example, if I choose a height of 1 and a width of 1, that basically means 1 cell. If I was to choose a height of 2 and a width of 2, that would be a selection of 4 cells. So if I close this bracket now and hit enter, I should find that the result I get returned is the March value for the North region. And if I take a look at that just there, that is exactly what I've got. So you specify your starting point, you specify how many rows you want to move down, how many columns you want to move across, and then basically how many cells you want to select from that point. That can be one cell, or it can be multiple cells, a range of cells. So let's do it again and take a look at what happens if we select a range of cells. So equals offset. I'm going to use the same reference point, A3. This time, let's say I want to return the July figures for the South region, and I want to basically return July to December. So rows, how many rows do I need to go down? Well, 1, 2, 3, 4, 5, 6. I need to go down 7 rows to get to July. I want to return them from the South region, so I need to go across 2 columns. Now, because I want to return all of the results from July to December, the height is going to be 1, 2, 3, 4, 5, 6 cells effectively. But I only want to return them from 1 column, so it's going to be 1 for the width. Close the bracket, hit enter, and it's going to return all of those results. Those should exactly match what we have just there. Let's do it one more time so you get the hang of this. Equals offset. Let's choose a different reference point this time. Let's choose cell E3, comma. How many rows do I want to go down this time? Well, I'm going to select a random region in the middle. So let's go down to the April value for the East region. So I need to go down 1, 2, 3, 4 rows. Now I need to go back 1 column. So for this, we can use minus values if we need to go back. So minus 1. I can then specify my column height and my column width. Now I'm going to say I want, let's just do 2 and 2. Close the bracket. Let's see what we get. So it's bringing back this range just here. We moved down 4 rows. We moved back 1, and then we said that we wanted a range that was 2 cells in height and 2 cells in width. So that is basically how the offset function works. Now you might be thinking to yourself, okay, I get it, that's totally fine, but how is this function useful to me? Well, let's take a look at a practical example. Now, if we go across to this next spreadsheet, you can see here I have an offset formula and I've combined it with a sum function. And that's what I said, you quite often see offset combined with other functions to create a really powerful formula. Now, what it's done here is it's looking at my little table and it's summing together the last 3 months of sales figures. So basically, these figures just there are being added together to produce this result. Now, why would we use offset just here? Well, it might be that with this data, every month new sales figures get added to the end. And if I was to add another month on the bottom here, so let's just drag this down, and let's say 1,500. Notice that the sales figure has now updated to $4,000. So I've added a new value on the end. It's still looking at the last 3 months. So if I select these cells, you can see down in the status bar, the sum is actually 4,000. So it's adjusted the positions once I've added a new value onto the bottom. And I haven't had to change anything in the formula. Now it's done that because I'm using the offset function. So I'm going to undo just to get rid of those values, and let's go through how we constructed this. Now I'm combining offset with sum because I want to basically add up the last 3 months. Now for this example, let's do the last 6 months. That's what I want it to add up. So we need to start this calculation with a sum function and then go straight into our offset. So now we have our arguments. Let's choose a reference point. I'm going to choose cell B3, comma. We now need to specify how many rows we want to count down. Now, if I was just to put something in here like 5, this formula isn't going to work because that number's hard-coded in. It's not going to adjust its position when I add new data onto the bottom. So here, in order to find the rows, we need to do a count A. And we want to count all of the values in this range, B4 to B15, comma. Now I don't want to move across any columns, so I'm going to put a 0 in here. And then the height, well, I want the last 6 months of data. So we're going to go from the bottom because we want the last 6 months, so effectively -6 needs to go in here. And then our last argument is width. Well, it's the width of one column, so we want to have a 1 on the end here. Let's close off our offset and close off our sum and hit enter. So I'm getting a result of 6,300, and if I check that simply by highlighting the last 6 months of values, so 1, 2, 3, 4, 5, 6, let's take a look in the status bar. That's the quickest way. The sum calculation there is 6,300, which matches my result in cell E4. Now let's see what happens if I add some more data onto the bottom of this table. So I'm just going to add another month. Let's add a value of 2,000 in there. Now notice that this formula hasn't automatically updated to include that new value, because now the last 6 months, the sum of those 6 months, should equal 7,500, and my result is still showing the old total. Now I can see that I've got a green triangle in the corner, so what I could do is click here, click the triangle, and I could update the formula to include the new cells. That is one way of fixing this problem. The other way that I could fix this would be to modify this formula so that my cell range extends past the last value that I have in here. So instead of B4 to B15, I might change this to something like B23. So let's go up to the formula bar and change B15 to B23. Now if I hit enter, I get the correct result because my new result is being included in the formula. Another way of doing this would be to use a table. So if I click in my data set, Control A, Control T, yes, my table has headers. Let's click on OK. And you can obviously change the formatting of that table if you want to. What I can then do is add another month, and the table auto expands to accommodate that. So when I add in a new total, you can see that now that total automatically updates. Let's just double check that that is exactly the last 6 months. And if I look down in that status bar at that sum total, yes, 10,600. So you have 3 different methods there to get offset to update automatically. You can click on that warning triangle, you can extend the formula past the end of your data, or you can put your data set into a table. So that is a practical use of offset with the SUM function. In the last lesson of this section, we're going to take a look at the indirect function. Now, what the indirect function does is it indirectly references another cell to return a result. So let's take a look at a very basic example of indirect in action. So I'm just going to go somewhere down here on the spreadsheet. Let's select cell I10, and I'm going to type in another cell reference. So let's go for, let's say K10 in here. Now in cell K10, maybe I have a number like 300. So what I could do over here is I could use indirect, and notice that we have 2 arguments. The first argument is the reference text. So I could select this cell just here, close the bracket and hit enter, and the result I get is going to be 300 because I've indirectly referenced this cell over here. The indirect function is referencing directly cell I10, but in cell I10 we have a cell reference to cell K10, and cell K10 contains 300, which is why we're getting the result of 300. So that is indirect in its most basic form. So again, you might be looking at that and thinking, okay, I understand that, but how is that going to be useful to me? Well, let's take a look at our first practical example. What I have here are a number of sales managers, and we have the different regions, north, south, east, and west, and the amount of sales each of those managers have generated. And basically what I'm trying to do here is in cell H4, I want to pull back the total sales for whatever region I have in cell G4. Now you might be thinking to yourself, well, can't you just do a sum calculation here? Well, yes, I could. I could say equals sum. We're looking for the north figures, so I could select this range just here, close the bracket and hit enter, and it's going to give me the total sales for the north region. Notice in the formula that I have the different regions set up as named ranges. Now the drawback with this is if I was to change the region, so let's change that to south, my values don't update because I've got nothing in this formula which is referencing these region names. So I can get around this by using indirect with sum. So we're going to start out with sum and we're going to go straight in to indirect. Now our first argument is the reference text. So the reference text I'm going to use to do this sum calculation is the region that we have stored in cell G4. Let's close off our indirect function and close off our sum. So if I hit enter now, I'm getting the total sales for the south region. And if I select this cell range and take a look down in the status bar, I should find that my sum calculation matches what I have in cell H4, which it does. Now the advantage of doing it this way, because we are indirectly referencing this range of cells via this cell just here, if I change the region, so if I change that to north, the figures are all going to update. So that is one practical example of how you can use the indirect function. Let's look at something now a little bit more complex. Now on this spreadsheet, I have a list of different tours, or the countries that these tours go to, and I have how much those tours have generated in sales from January to July. And right at the bottom, I have a totals row showing me the totals for each of those months. Now what I'm interested in when I'm looking at this worksheet are basically the total sales for the month just gone, so effectively the current sales. So the current sales is always going to be this value here. It's going to be the total for the previous month. Now bear in mind, this data is going to change each month. So next month we're going to have another column in here, which is going to have all of the August figures. So we need to build our formula so that as we add columns of data in, the current sales is always updating. So it always moves across one, across one, across one to grab that total sales figure. And we can use indirect to help us do this. So let's click in cell K4. We're going to type in equals indirect. Now this time we're going to use both of these arguments. Now the first argument here is reference text. Now one thing you need to understand is when you're working in Excel, there are two different ways that you can reference cells. Now the most common way is to use cell references, so A1, B2, C3, so on and so forth. The other way that you can reference cells is to use what we call R1, C1 referencing. And the only difference with this is that R1, C1 lets you specify the row and the column. So if we just come out of here for a moment so you understand what I mean, something that was written out like R10, C2, that would basically mean row number 10, column number 2. That is R1, C1 referencing. Now for this formula that we're constructing, we need to use that style of referencing. So let's type in indirect. There it is. So the reference that we're going to be using this time is R1, C1 style referencing. And what do we actually want to reference? Well, we want to reference the total row. That contains the value that we're interested in. So the total row is row 15, but the column that we're choosing is going to change depending on how many columns of figures we have in this table. And remember, that's going to change each month. So we need to do something a bit different. Now, when we're using this R1, C1 style, we need to put this in quote marks. So the first part of this is fairly straightforward. We want to reference row number 15. But when it comes to the column that we want to reference, I don't know the number of the column because it's going to change each month and we need to allow for that. So I'm going to add some more quote marks and we're going to use the ampersand to concatenate. And then we're going to go straight into a count A. We're going to get Excel to count the total number of columns in order to find where that last column is. and we're going to count in row 15. Now the reason why I'm selecting the whole row here is because this is going to accommodate any new rows that we add. Let's close the bracket. And then the last argument on the end here for this indirect function is the style of referencing that we're using. Now we're using R1C1 style in this case, so we need a false argument on the end. And let's close off our indirect. Now this is a reasonably complex formula that I'm showing you here. This might be more suited to the advanced Excel course. But I thought I'd throw this in here just so you can kind of get an idea as to how you can combine these functions together to get the result that you need. So let's hit enter and see what we get. What we should get is the total for the last month, which is July. And I can see that yes, we do. Now I'm just going to apply a little bit of formatting so this looks the same. So the way that we've constructed this formula, if I was to add another column in here, so I'm just going to copy this across and let's change this. So we've got August there, and let's change some values so that we have a different total. So let's say 5,000, we'll go 10,000 in here. Let's drag the total across, and would you take a look at that? Now this is updated and it's showing me the new month's total. So we've introduced a lot of new concepts in there. We're just getting our head around how indirect works. We've also introduced the new R1C1 style of referencing, and we've introduced a little bit of concatenation and how you can use count to find the last value in the last column and future-proof this formula a little bit for when you add new columns onto the end. This one is definitely one that you should have a little practice and play around with so that you really understand exactly what you're doing when you're using this style of formula. But hopefully that gives you a better idea as to how indirect works and a couple of practical examples of how you can use it. It's time now for us to do exercise 2. And in this exercise, we're going to practice some of the skills that we've learnt in relation to lookup functions. So we have a table on this worksheet that just shows us some athlete names, their bib numbers, the event that they ran in, the route that they took, and the position. So this is really an athlete's finishing table. And what I'd like you to do is in cell H3, I'd like you to create a data validation drop-down list that lists out all of the athletes. And just a quick tip here, all of the athletes in column A are unique, so we don't have any duplicates. I'd then like you to construct a formula using a lookup function of your choice so that when we select an athlete from the drop-down, it's going to return their bib number, the route they took, and their position. And the final thing I'd like you to do is just add some error checking into your formula. So it might be that you add if error, or maybe you add if NA, just to make sure that if there is an error in this data, we're handling that error with a meaningful message. See how you get on with that, and if you want to see my answer, then please keep watching. So the first thing we need to do here is create a data validation drop-down list in cell H3 that lists out all of the athletes. So let's click in cell H3, up to data, and into data validation. Now we want to create a drop-down list, so let's select that from the menu, and our source is going to be the athlete names. So Control-Shift down arrow to select all of them. Let's click on OK. So now I should find that I have my little drop-down list with all of the athletes listed out. Time now to move on to our lookup formula. Now for this example, I'm going to use index and match. But if you'd rather use VLOOKUP or even XLookup, then please feel free. So we're going to do our index, our array. So what are we looking for here? We're looking for the bib number. So our array is going to be the bib number column, B4 to B27, comma. We now need to find the row number. So we're going to go straight in with our match because we're going to match the athlete name. That's going to be our lookup value. We want to match the athlete name in the athlete name column, Control-Shift down arrow. comma. We want to do an exact match of the athlete name, close off match, close off index, and hit enter. Now it says NA in there. And if you remember, I said I'd like you to add some error checking into these formulas. So what I'm going to do is I'm going to go straight up to the formula bar, and we're just going to wrap this in an if NA. And if we do come across an NA, we want it to say not found, like so. So now if I select an athlete, I should find that it either tells me what their bib number is, or if it can't find it in the table, it's going to come up with not found. Let's complete our other two index and match formulas. So equals index. This time we're looking for the root. So that is going to be our array. Control, Shift, down arrow, comma. We automate the finding of the row number by using match. Our lookup value is whatever we have in H3. We're looking up the athlete name in the athlete name column, and we want to do an exact match. Close off match, close off index, hit enter. And remember, you could also add your error checking into this formula. Let's do the final one. This time I'm going to switch things up and I'm going to use a VLOOKUP. This time I need my lookup value, which I'm going to find in cell H3. My table array, well, this is my table array over here. I'm going to select everything. Which column do I want to return? Well, I want to return the position. And counting from left to right, I can see that this is column number 5. What type of match do I want to do? Well, I want to do an exact match, so we want a false argument on the end. Close the bracket, hit enter, and I get my result. Let's double check to make sure this is correct. So let's find Donald Holland. His bib number is 1090. He ran the east loop route and he finished in position number 7. In this section, we're going to talk about sorting and filtering data, because sorting and filtering are two of the primary tools when it comes to helping you analyze your data. And we're going to start out in this lesson by running through how to sort on multiple columns. Now, when we sort our data, it basically allows us to organize our data into a more logical format that is a lot easier for us to read and interpret. And most of us know how to do a basic sort. So for example, if I wanted to sort this table of data by the last name in alphabetical order, I could click in that column, and then I have a few different options when it comes to sorting. I could use my Home tab. Over in the Editing group, I have a Sort and Filter drop-down, and I can choose to sort that column in A to Z order or Z to A. I could also right-click my mouse, and I have sort options in here, once again, A to Z or Z to A. And I have a third option of the data ribbon. In the Sort and Filter group, we have Sort A to Z and Z to A buttons in here. Now, I'm not going to demonstrate those because this is an intermediate course, so by now we should know that that is how you do a basic sort. What I want to focus on in this lesson is how we can do a more advanced sort where we're sorting on multiple columns. So a lot of the time when you're faced with a data set, you don't just simply want to sort by one column, you want to sort by maybe 2, 3, 4, 5, so on and so forth. And in fact, you can sort by every single column in your data set if you wanted to. So let's take a look at how we would perform a sort on multiple columns. Now for this particular sort, you don't need to click in any column in particular. And as we're already on the Data tab, I'm going to use the Sort button that we have in the Sort and Filter group. So when we click on this larger button, it's going to open up this little Sort dialog box. And this allows us to choose which columns we want to sort on. So if I click this first one, where we have Sort By, it's going to show me all of the columns that I currently have in my data set. So I want to sort by the last name first of all. I can then choose what I want to sort on. So I can sort on cell values, cell color, font color, or a conditional formatting icon. Now, in this example, we're going to sort on the cell value, and then I can choose my sort order, A to Z, Z to A, or using a custom list. And I'm going to show you how to sort using custom lists in the next lesson. For the time being, I'm just going to sort by last name, A to Z. Now if I then want to sort by another column, I can simply add a level and then repeat this process. So once we've sorted by last name A to Z, I might then want to sort by the city on the cell values A to Z. Add another level, and this time let's sort by the town on the cell values, but this time let's do Z to A. And I could carry on going in the same way. If I want to copy a level, I can. I have a copy level button above, and that's just going to give me another one just here. If I want to delete a sort, I can select it and click Delete Level. And I can also reorder my sorts. So if I decide that I want to sort by the town first of all, I can select it and move it up to the top of the list. Now I don't, so let's put that back down again. And then we have an options button in here as well, which allows us to specify if our sort is case sensitive, and we can also choose the orientation of our data. So when I have my data organized in this way, so vertically with my column headings in the columns, I want to sort top to bottom. But if I had my data organized horizontally, I could choose to sort from left to right. So don't forget about that options button. So let's click on OK and see how that affects our data set. Well, there we go. So the first sort I did was to sort by last name A to Z, and I can see that yes, that looks to be correct. I'm then sorting by city A to Z. So this becomes more obvious when we go down to a last name where we have two entries. So here we have two entries where the last name begins with C, and these two should be in alphabetical order. So East Sussex and then London. The same here for Hernandez because we have two of them. These are in A to Z order. And then finally we sorted by town Z to A. So our sort appears to be working correctly. Now you're not just limited to performing multiple sorts using the cell value. For example, if I had some rows in my data that had a background fill, so I'm just going to go through and let's just fill these. Let's fill them with a bright yellow. I'm just going to do a few rows just here like that. What I could do if I wanted to bring all of the highlighted rows to the top is I can sort by the cell color. So once again, let's right-click this time and take a look at a different way of getting to our sort options. I can right-click, go to Sort and Custom Sort. And what I'm going to do is just delete out the current sorts that we have applied. So now I can add a level. I can choose to sort by, and let's go for last name again. But this time, instead of sorting on the cell values, I'm going to sort by the cell color. And then I get an additional box just here called Order, and that's going to pick up all of the background fill colors that I have in this data set. So I only have one, so I want to sort by the yellow background fill, and I want to place those items at the top of the list. Let's click on OK, and it pulls those to the top. Now I'm going to undo a few times just to remove that yellow background shading, because the same works if the font is a different color as well. So let's just make these, a few of these red, for example, those ones just there. And this time we're going to use the home ribbon in the editing group, Sort and Filter, and Custom Sort. Once again, I'm going to delete out all of these current sort levels, add a new level. I'm going to sort by the last name, but this time we're going to sort by font color. Now when I click the drop down here, you can see I have two options because my heading rows contain a light blue colored font. So I want to sort by the red font entries. I want them on top, click on OK, and those are pulled to the top of the list. And in the same way, if I had conditional formatting icons in any of these cells, on the conditional formatting icon and bring those entries to the top of the list as well. So pretty easy to sort. Have a little play around with that and see how you get on. So now we know how to sort on one column or multiple columns. The final sort option I want to show you is how to sort using your own custom list. Now, what do we mean by sorting using a custom list? Well, it might be that you have a data set that you want sorted in a very specific way. One that is outside the boundaries of simply sorting A to Z or Z to A. For example, if we take column A just here, you can see that I basically have three items, Miss, Mrs, and Mr. Now, if I want to sort this dataset A to Z, I can right-click, go to Sort and A to Z, and it's going to put the misses at the top, the misters in the middle, and the misses at the bottom. If I right-click and sort Z to A, it's going to put the misses at the top, the misters in the middle, and the miss at the bottom. Now, in either of those two options, I don't get Mister at the top of my sort. And what if I actually need that? Maybe I need to sort this list by Mister first, then Miss, then Mrs. Well, this is where we can use a custom sort. Now, the first thing you would need to do here is basically write out or type out your list in the sort order that you prefer. So, in a blank cell somewhere over here, I'm going to write my sort order. So I want Mr. first, then I want Miss, and then I want Mrs. And I can set this up as a custom list. So to create a custom list, we need to go into File, down to Options, and into our Advanced Settings. Now, if we scroll all the way down to the bottom, and it is quite a way down, in the General section, we can edit our custom lists. And custom lists are basically those lists that when you type the first one in, you can then use your fill handle to drag down and complete the others. And you might be more familiar with that when you're typing in dates or months of the year. You can see that I also have some other custom lists that I've created in here as well. So I'm going to set up my sort order as a custom list. And because I have them typed out in the cells over here, I can choose to import them. Now, you don't have to import them from cells in a spreadsheet. You could choose to create your own new list and simply type the entries in this box here. But we're going to import them. So let's just simply select the list and click Import. So there is my new custom list. Let's click on OK. And OK again. So now I have those set up as a custom list. What I can do is use that custom list as the sort order for my data. So on the Home tab, let's go to Sort and Filter and into Custom Sort. So now I'm going to sort by the title. I want to sort on the cell values, but the order I want to use is determined by a custom list. I can then just simply select my custom list, click on OK again, and it's applied my very specific sort order. Now, if I was to go and delete these entries from here, let's just delete those out, it doesn't affect that sort order at all. It's time now to talk about two new functions in Excel 2021, and that is sort and sort by. So now, instead of using ribbons and commands in order to perform a sort, we actually have some very specific functions which are going to help us sort. And sort by are brand new functions in the latest version of Excel, and they're part of a list of new dynamic array functions. Now, both of these functions are classed as lookup and reference functions. So if you're looking for them in the functions library, you'll find them in the lookup and reference group all the way at the bottom here, sort and sort by. So let's have a quick demonstration of both of these so you can see how they work and how they might be useful to you. So let's start out with the sort function. Now, the data that we're going to sort is, again, some very basic data. We have some students, we have the block that they reside in, an exam that they've taken, and their pass mark. And we're going to use the sort function to sort these results. Now, previously, when we've been doing sorts, we've been right-clicking and selecting different commands to use here. And all of these commands really rely on you already having your data in the table in order to sort it. Now, with the sort function and also the sort by function, we can basically output this data into a different range of cells, but the data that we output is going to be sorted as we want it to be organized. So what I've done here is I've copied across the column headings into another range of cells. And we're going to use the sort function to sort this data. So let's click in block and type in equals sort. Now we have 4 arguments here, and notice that 3 of those are optional arguments. The only one that's mandatory is the array. Now, the array is basically the cell range that contains the data that you want to sort. So for this sort, my array is going to be all of this information just here. Now, notice that I'm not including the column headings there. I don't want those included in my sort. Now, because that is the only mandatory argument, I could stop my formula there and close the bracket. And if I hit enter, it's going to sort my results effectively by that first column. The default is to sort my results by the first column, A to Z. So this list is now sorted by the block in A to Z sort order. Now that might be absolutely fine, and if that's what you want to do, then you can just leave it just there with one argument. However, what if I want to sort by one of the other columns? So maybe I want to sort by their mark in descending order. So I have the highest mark at the top going all the way down to the lowest. So let's undo. This is where we can use some of these other arguments. So I'm going to select my array again. That's this range just here, comma, sort index. So this is where I tell Excel what column I want to sort by. And much like VLOOKUP, which numbers columns from left to right, this works in the same way. So my sort index is going to be a column number. So if I want to sort by the mark column, that is column number 4, comma. The sort order is where I can specify if I want to sort in ascending order or descending order. Well, I want to sort in descending order because I want the highest pass mark at the top going down to the lowest. So my argument here is -1. And then the final argument on the end, which again you don't have to put in, is if I want to sort by the column or sort by the row. And I will say the majority of the time you're going to sort by the row, so we want a false argument on the end there. Let's close our bracket and hit enter and see what we get. So now I have my results sorted in descending order by the mark. So very simple and straightforward. And because these are dynamic arrays, it means that if any of this data changes, then my sort is also going to update. So if I make a change to, let's say, the block just here, maybe I want to have East Wing in here and hit enter. Notice how it's also changed in the sorted results. Now I'm going to undo that. Now what if I added another entry on the bottom here? Is my sort going to update? Well, let's add East Wing at the bottom and press Tab. Notice that it doesn't update. Now I could get around this problem by putting this data in a table first of all. Because remember, with tables, they auto-expand to accommodate any new information. So let's do this again. But let's put our data into a table first of all. So Control T to create a table. Yes, my table has headers. Click on OK. You could go in and change that formatting. I'm not going to bother right now. Let's do our sort. So let's say equals sort. I want to sort by this range just here. And notice now, because I have this data in a table, it's giving me the table name, which is simply table 2 because I haven't renamed it. My sort index, well, this time let's sort on the student name A to Z. So the student name column is column number 2. I'm going to sort A to Z, so I'm going to say ascending order, and I don't really need the last argument on the end, so let's just close the bracket and hit enter. So now I have this list sorted by student A to Z, and because this is in a table, if I add another entry on the bottom, so let's say East Wing, as soon as I press Tab, take a look at that. It automatically adds it to the bottom of this list. Let's just add the rest of these details, like so. So think about incorporating tables if you want everything to dynamically update. Now, when I'm making my table array selection just here, I don't necessarily always have to select the entire data set. For example, if I just wanted to extract the block and the student name, when I do my sort over here, when it comes to the array argument, I don't have to select the entire table. I could select just the columns that I want to sort. So block and student. Let's go all the way down to the bottom. Again, notice what I have in my formula. It's giving me my formula name and then both of the column names. I want to sort by the student name, so that is column number 2. And this time let's sort in descending order, -1. Close the bracket, hit enter, and there we have our information sorted. And just another point on that, if I wanted to sort by these 3 columns, so let's just copy and paste those over there. When I do the sort this time, my array, I only need the student, the exam, and the mark, so I can select this array just here. Now, when it comes to the next argument where we select the column isn't going to be column number 2, it's column number 1 of the selected array. So our sort index, in this case, if we want to sort by the student, is going to be column number 1, and then we can do our sort order, let's say ascending, and hit enter. So a few different examples there of how to use that sort function. Now, one little thing here is you cannot perform a sort on non-contiguous columns. So you can't sort data that isn't next to each other. So for example, I couldn't have 2 column headings over here for, let's say, student and also mark, because the student column and the mark column have an exam column in between. They're not adjacent, they're not next to each other. So now we know how sort works, let's take a look at sort by, because it's a very similar thing. Now this function will allow us to specify which column we want to sort by, so kind of similar to sort in many ways. We have the same data, so let's see what sort by can do for us. Now the first argument here is the array. So again, I'm going to select all of the data that I want to sort. Our next argument is by array 1. So I can go in and choose the column that I want to sort by. So maybe I want to sort by the mark, so we're going to select this column. And then we need to provide the sort order. So I want to go from 100 down to the lowest mark, so we're going to say in descending order -1, comma. My next argument is by array 2, so this method allows me to sort by multiple columns, because my by array 2 argument will let me go in and select another column, a second column to sort by. So this time I'm going to sort by the block, so let's select that column, and I'm going to do that in ascending order, which is a 1 argument on the end. And I could carry on going. Let's do another column. I can choose another column to sort by, so let's do the student name, and I'm going to sort A to Z, which is a 1 on the end there. Now I'm going to leave it there. Let's close the bracket and hit enter, and there is my sorted list. I'm sorting by mark, then by block, and then by student. So now we've had a thorough look at sorting our data, it's time to move on to filtering. Now most of us are familiar with using the drop-down arrows to filter our datasets and extract exactly the information that we're interested in. But did you know that there is also an advanced filter option? And in my opinion, this is one of the most underrated commands in Excel, because it's not something I see talked about very often. So let's take a look at how the advanced filter works, because it has many uses. Now in this first example, I'm going to show you how you can use the advanced filter to extract a unique list of values from your dataset. So if we take a look at the table on the left-hand side, I have a list of sales reps, I have the region that they belong to, and then their sales information. Now notice here in the sales rep column, I have the sales rep names repeated over and over again. So technically, there's only roughly 5 sales reps, they're just repeated throughout this data. Now maybe I want to extract from this column just a unique list of all of the sales reps. And I find this is something I have to do all the time. Now we can extract a unique list using Excel's advanced filter. So let's take a look at that first of all. So if I click somewhere over here, I'm going to say unique list of sales reps. And then underneath here, I just want the 5 or so names of the sales reps. So what we can do here is jump up to the Data tab, and in the Sort and Filter group, we have an Advanced Filter option. And you can see here with the screen tip, it says it contains options for filtering using complex criteria. So let's click on Advanced. Now, the thing with this advanced filter, when this little pane opens up, is it does hold in it the last criteria you used. So we're going to delete that out in a moment. But the first thing we need to specify is what action we want to perform. Now, do I want to filter this list in place, or do I want to copy it to another location? Well, I want to extract a unique list of the sales rep names to a different cell. So we want to copy to another location, and then we have 3 blank fields to complete. Now, when you're extracting a unique list of records, we only actually need to complete 2 of these. And the first one is the list range. So where are the values that we want to extract? Well, they're in the sales rep column. Now, for this one, we don't need to specify any criteria, but we do need to let Excel know where we want to copy these unique values to. And I want to copy them to this cell just here, F11. And the most important thing is to make sure you select unique records only. When we click on OK, take a look at that. I now have my unique list. Now, there is a way to do the exact same thing by using a formula. And this is, again, one of those new formulas in Excel 2021. And I'm going to show you how that works in the next lesson. But for the time being, you can also use your advanced filter to extract a unique list of values. Now, what else can we use this advanced filter for? Because that is by no means all we can do with this. Well, let's jump across to our next worksheet where we have the same data. We can also use the advanced filter to extract values based on specific pieces of criteria. And the way this works is you have to have your criteria listed out in your spreadsheet. So you can see here in this little table over here, I want to extract from this table all of the records where the region is Asia and the sales total is greater than 7,000. And we can do this again using our advanced filter. So I'm going to click somewhere underneath. Let's click on Advanced. Now I want to copy to another location, so let's make sure we select that underneath Action, and then I'm just going to delete out all of this old criteria. Now for this one, we are going to utilize all 3 of these boxes. Now the first thing we want to select is the information we want to extract. Well, I want to extract the date, the sales rep, the region, and the sales information. So basically everything in my table. So my list range is going to be my entire table. I then need to specify my criteria range. And I have my criteria listed in this small table just above, so I need to select the entire little table. Then I can specify where I want to copy these results to. So let's click on cell F9. I don't need to select unique records this time, because that's not what we're doing. All I need to do here is click on OK. And take a look at that. I now have a filtered list that's showing me just the records where the region is Asia and the sales are over 7,000. So effectively what we've done here is a filter using AND criteria. Filter for Asia and sales greater than 7,000. Now I can also filter using OR criteria. So let's take a look at what that would look like as well. So I'm just going to clear everything from here and let's change our filter criteria. Now, if you want to do an OR, your criteria needs to be listed one above the other. So maybe I want to filter for records where the sales rep is Ben or Deb. And let's just keep our formatting consistent. Let's just apply that. And let's also apply that like so. So now I have these in here, it's going to do an OR filter. So let's go back to our Data tab, into Advanced, and we're basically going to do a very similar thing. We're going to copy to another location, and let's remove all of these. I like to start from a clean slate. Our list range, well, we want to pull back all of the information, so we select the entire table. Our criteria range is this table just here, and we want to copy to this cell and click on OK. And now I should find that my filtered results are only for the sales reps Ben or Deb. So that is how the advanced filter works. It's great for extracting unique lists of information, but it's also great for filtering data using more complex criteria. In the last lesson, I showed you how you can use the advanced filter to extract a unique list of values. And I mentioned in that lesson that now in Excel we have a brand new for Excel 2021 function that'll do exactly the same thing. And not surprisingly, it's called the unique function. And I have to say that if I need to extract a list of unique values, this is my go-to method. I don't tend to use the advanced filter as much as I do unique. And I'm sure this is one of those functions that you're going to find yourself using all the time. Now, the unique function does exactly the same as the advanced filter. It lets us extract a unique list of values. So if I want to use the unique function to extract a unique list of all of the sales reps, all I need to do is click in a cell and type equals unique. Press the tab key. Notice I have 3 arguments. Now, the last 2 arguments are optional arguments. They're showing in square brackets. So if you simply just want to extract a unique list, you only need to specify the array argument. So the array argument is basically the column that contains the unique values, B5 to B28. So all I need to do is select it, close the bracket, hit enter, and I get my unique list of values. And because this is a dynamic array, if any of these were to change, this list is going to update as well. So if I was to change one of these to Mark, you can see it now adds Mark onto the end of the unique list of sales reps. Now, once again, if I was to add something to the bottom of this list, so if I just drag this down and let's say Matthew, it's not going to update that unique list because we've chosen to extract this unique list from this range only. It stops short of any new items added onto the end. So of course we could combine this with a table which will auto expand and our dynamic array will update automatically. So let's just take a look at that. Let's click in our data, Control T. Yes, my table has headers. Let's click on OK. Now I'm going to give my table a name. So let's click on Table Design. And in the Table Name group, let's call this Sales Reps and hit Enter. So now I can use this table and this will be completely dynamic. So I want to extract my unique list from the Sales Rep column. And notice because I've put this data into a table, the annotation is different. It's showing me the table name, which is sales reps, and then I have the column that I've selected in square brackets. So if I close this and hit enter, I get that same unique list. But if I was to add another entry on the bottom, so let's just drag this down and add in Matthew, when I press the tab key, you can see that that unique list now dynamically updates. So just bear that in mind when you're working with this unique function. Now, as I mentioned, when you're using unique, there are some other arguments, some optional arguments that we have. So let's just take a look at how those work. So let's type equals unique again. The array, well, let's stick with the sales rep column, comma. Now I can specify if I want to return unique columns or unique rows. So if I was to choose the true argument here to return the unique columns, if I had column headings that were repeated running across the top, I could use the true argument just to extract the unique columns. I will say that most of the time you're going to use this to return unique rows, and that is in fact the default if you don't specify this option. So let's just type in false. And the last argument we have here allows us to either return items that appear exactly once in our range or return every distinct item. So if I want to return the 6 individual sales reps, I would use the false argument. And again, that one is the default if you don't specify anything. But what about if I just wanted to see sales reps that appeared exactly once in my selected range? And because I've just added Matthew on the bottom here, he only occurs once in this list. So if I just wanted to see Matthew, I could use true on the end here because it's going to pull back values that occur exactly once. hit enter. Oh, I actually have two. Yes, I do. I've got Mark in here. He only occurs once as well, and also Matthew. So those are the additional arguments that you have when using the unique function, a super useful function that I think you're going to find yourself using all the time. In the final lesson of this section, I'm going to show you how you can use yet another new function in Excel 2021. There are so many of them in this latest release. And that is the filter function. Now we've seen how we can use our drop-down arrows to filter. We've seen how we can use the advanced filter to extract filtered results. And now I'm going to show you how you can utilize the filter function to do a similar thing. So let's start out basic and then we'll build up into a more complex filter. So we're going to use our good old student data again. And what I'm aiming to do here is I want to filter for all students who sat the English exam. And I want to output that list of students into this range of cells over here. And we're going to use the filter function in order to do that. So let's click in cell H5 and type in equals filter. Now for this particular function, we have 3 arguments, with the last one being optional. Now the first argument here is the array. So what results do we want returned? Well, I actually want all of the results returned because I want to know the block, the student, the exam, and the mark. So the array is going to be everything in this table, A5 to D29. And remember, if you do want to make this completely dynamic, then you can put this data into a table beforehand. Comma. Now we need to tell Excel what we want to include. So this is effectively where we specify what we're filtering by. Now we're filtering by the exam English. So we need to say we want to include the exam, and we select the range here, when it equals English. Now I've got mine listed out in a cell. If you wanted to hard code this in, you could just simply type in English in here and put it in quote marks, and it would effectively do exactly the same thing. But as we have it listed in a cell, I'm going to use the cell reference. Now those are the only 2 mandatory arguments, so I could close off my bracket and get my results. But let's just take a look at that final optional argument, if empty. So what we can do here additionally is specify what we want it to say if the result of this filter is nothing. So if it doesn't match the word English in this table, what do we want it to say? So I'm just going to say, just produce a blank cell. So 2 quote marks. Let's close the bracket, hit enter, and see what we get. Now take a look at that. I'm now getting a list of all of these students that sat the English exam. So this works really well. And if anything changes within this data, then this is going to update. But if we add new values to the bottom, we would need to make sure that this data is in a table in order to get our filter to update dynamically. So that is how you can use the filter function when you have one piece of criteria. So in the next example, let's take a look at how we can filter by multiple pieces of criteria, multiple columns effectively. So let's jump across to the next worksheet. So now let's just delete out these results. I have pretty much the same thing, but we've added in a piece of criteria. Now we want to filter for all the students that sat the English exam who reside in the West block. So we have 2 pieces of criteria, so we need to structure our formula in a slightly different way. So let's type in equals and filter. Again, the first thing we need to specify here is our array. What do we want to return? Well, I want to return everything, so we're going to select all of the data. Now we need to specify what we want to include. So this is where we set up our filter, or in this case, filters, because we have 2. Now, because we have multiple filters, we need to enclose them within brackets. So our first filter is the exam. So we need to select the exam range, and that needs to equal English. Close our bracket. That is our first filter. We now need to specify our second filter, and we separate our 2 filters with a multiplication sign. Let's open our bracket and do our next filter. So this second filter, we're filtering for the block West. So we need to select the block range, and that needs to equal West. Close off the bracket. Now I could carry on going. If I had more pieces of criteria, I would just type in another multiplication sign and carry on going. But we only have 2 in this example. Let's press comma and let's specify what we want it to say if it doesn't find any records. Now this time I wanted to say no records, and that needs to go in quotes and close off our bracket. Let's hit enter, and there we go, we have our results list. And if this exam changes, so maybe now I want to see the results for the French exam, that's going to update, and the East block. Maybe I want to see results for the maths exam. Now take a look at that. The maths exam for the East block has no records. Now I do have a small typo there, so let's just retype that to make sure that that still works. Yes, it does. So this is all extremely dynamic. Now in the final example of using filter, I want to apply 3 filters this time, but I also want to sort my results. And we can do this by combining the filter and the sort functions together. So this time I want to filter for all students that sat the English exam who are located in the West block and who have a pass mark that's greater than 50. So let's click, and the first thing we need to type in here is we need to type sort and then go straight into our filter. What are we filtering for? What do we want to return? Well, we want to return everything in this list, comma. Now we can set up our filters, and this time we have 3 separate filters. Now remember, if you have multiple filters, they need to be enclosed in brackets. So our first filter is going to be when the exam equals English. That's our first filter. We separate our separate filters with an asterisk, and now we can specify our second filter. So when the block equals West, close off that filter, and we have a third one, so asterisk again, open a bracket. When the mark is greater than 50, close the bracket, comma. We now have that optional argument where we can specify what we want it to return if it doesn't find any results. So I'm just going to say once again, no records. Let's close off our filter, and we're now back into our sort. So this is where we can specify exactly how we want this list sorted. And what I'm going to say is here, once I get my filtered results, I want to sort them in descending order by the mark. So the first argument for sort is the array. Now the array is going to be generated by that filter function. So we can press comma to move on to the next argument. This is where we specify the sort index, so the column that we want to sort by. And remember, when we were looking at sort numbers columns from left to right. So I want to sort by the mark column, which is column number 4. Comma. Now I can specify if I want to sort in ascending or descending order. Well, I want to sort in descending order, so we want a -1 in here, comma. We do have an optional argument on the end here. We don't actually need this, so I'm not going to add it. Let's close off our sort, hit enter, and take a look at our results. So we're only seeing the English exam for the West block, and the marks are all above 50, and they're sorted in descending order by the mark. So if I change this filter and take this mark up to 80, you can see my results update. Let's put that back down to 50. If I change the block to East, I get one result. If I change the exam to French, I get a different set of results. So we've managed to really effectively combine their filter and sort to get a really nice filtered and sorted list using dynamic functions. It's time now to do exercise 3, where we're going to practice some of the skills that we've learnt in this section on sorting and filtering. So there are a couple of different things I'd like you to do here. Once again, we have on the left-hand side just a small table. It shows me some countries listed out, the regions those countries belong to, the revenue and the profit that they've generated. And the first thing I'd like you to do here is I'd like you to create a unique list of all of the regions. And I'd like you to do that using an Excel function. And then once you have that unique list, I'd like you to use that list to create a data validation drop-down list in cell F4. And then finally, if we cast our eyes over to the right-hand side, notice that I have the same column headings running across the top. I'd like you to create a filter that filters results by the region selected in cell F4. And I'd like you to include a meaningful message so that if there are no records, we don't get an error, we get a message that says no records. So to give you a little bit of an idea as to which direction to go in, you're going to need to be using the unique function and also the filter function to complete this exercise. And then the second part of this exercise is sorting data. So once again, we have similar information, and I want you to use the SORTBY function to sort the athletes by route and position in ascending order. So now is the time to pause the video, give the exercise a go, and if you get stuck or you'd like to see my answer, then please keep watching. So the first thing we need to do here is we need to create a unique list of the regions. So to do this, I'm going to kind of go over here. So I'm in a blank space, and I'm going to use the unique function. Now for this, all we need to do is to select the range. So we want a unique list of the regions. So Control Shift down arrow. I'm working up in the formula bar now. Close the bracket, hit enter, and there is my unique list. So now I want to use this unique list to create a data validation drop-down list in cell F4. So let's click in cell F4, up to data, into data validation. We're going to create a list, and the source for our list is going to be our unique list in column M. Click on OK. And now I have my little drop down arrow and I can select my different regions. Remember, if you don't want these visible in column M, you can simply right click and hide that column. Now the second part of this exercise was to create a filter that filters the results by the regions selected in F4. And I wanted you to add a meaningful message if there are no records. So what we're going to do here is we're going to use the filter function. Now for this, our array is going to be everything that we have in this table, and then we need to tell the function what it is we want to include. So I basically want to include all the records where the region is Australasia. So I'm going to include the region when it's equal to whatever we have in cell F4, comma. What do I want it to do if it's empty? Well, I want to add a message that says no records and close the bracket. Let's hit enter. And would you take a look at that? It's picked out all of those results from the table. And because this is dynamic, if I change the region to Europe, I'm going to get an updated list of results. The second part of this exercise was to sort our data. And I wanted you to use the SORTBY function to do this. And I'm going to sort the athletes by their route and position in ascending order. So once again, in cell G4, we're going to use the SORTBY formula. My array, well, this is going to be all of my data. So let's select everything that we have in here. I'm going to work up in that formula bar, comma. What do I want to sort by? Well, I want to sort by two things. I want to sort by the route and position in ascending order. So the by array 1 argument is going to be the route. So let's select everything that we have just there, comma. Sort order 1. Well, I want to sort in ascending order. So we're going to add a 1 just there. Comma. By array 2. So now I want to sort by the position. So we're going to select the position column, comma, and I want to sort by ascending order again. So a 1 on the end there. Close the bracket, hit enter, and would you take a look at that? We're now sorting by root first of all in alphabetical order. So I have east loop first and then west loop, and then we're sorting by the position. In this section of the course, we're going to delve into date and time in a little bit more detail. And we're going to take a look at some date and time functions a bit later on in this section. But in this introductory lesson, I just want to make sure that we all understand the theory behind dates and times in Excel, because it does work a little bit different. So on this worksheet, I have a small table with 3 column headings: short date, long date, and time. Now, currently, I don't have any date or time formatting applied to these numbers. And this is the first rule when it comes to dates and times in Excel. They are essentially just plain numbers underneath. They become dates and times when we apply the appropriate formatting. So if you've ever received a spreadsheet from a colleague or a client and you've looked in the date column and you see numbers which look something similar to this and you've wondered why those were there, it's because this column doesn't have date formatting applied to it. If I take a look up on the home ribbon in the number group, you can see that currently I just have general formatting applied. So whilst these are dates, they're not displaying correctly because I don't have date formatting applied. Now, what exactly are these numbers? Well, the way that Excel works is that it takes the 1st of the 1st, 1900 as day number 1, and all days are numbered from that point respectively. So the numbers that you see in here are basically the number of days past the 1st of January 1900. And if you have incorrect formatting applied to date cells, you're going to see that underlying number as opposed to the actual date. Now notice if I select this column of numbers, go to my numbering drop-down, I have 2 options in here, short date or long date. So let's start out by applying short date format, and now those look a little bit better. We could do a similar thing, but apply a long date format as well. So we have those same numbers. Let's go to the drop down, and we can apply long date format. I need to make this column a little bit wider by double clicking. And now I get the longer version of the date. And there are tons of different date and time formats that we can use, which we're going to take more of a look at in the next lesson. Now in the 3rd column just here, we have some times. And these look a little bit different from the dates, but they are effectively still numbers. But the difference with times is that when we don't have time formatting applied, which we don't in this column, we just have general formatting applied again, all times are a fraction of 1. So let me show you what I mean by that. I've got this little fractions column just here, and I've just added some numbers. So we have 0, then 0.25, 0.3, 0.4, 0.5, all the way up to 1. Now, if I just select these, and let's just make a copy of those cells, if I apply time formatting to these, like so, you're going to see what those fractions equate to. So 12 AM, according to Excel, is 0. 0.25, which is essentially a quarter of a 24-hour period to Excel, is 6 AM. 0.3 is 7:12. 0.5, so halfway through the day, is 12 PM. And then when we get to number 1, we're back to 12 AM. So Excel stores times as values between 0 and 1. They're effectively fractions. So again, if you see a spreadsheet that has times that look something like this is what those numbers represent. Now let's apply the correct formatting to these as well. I'm going to press Ctrl Shift down arrow to select all of the data, up to the drop down, and this time we're going to use time, and now those times look a little bit better. So that is the basis of how Excel stores dates and times in your spreadsheet. They're stored as values, and we get them to look like dates and times by applying the correct formatting. So now we understand how dates and times are stored in Excel. Let's move on to taking a bit of a closer look at custom formatting. And I'm also going to show you just a couple of little really useful keyboard shortcuts for quickly applying some common date functions. So if we start at the top of this spreadsheet, you can see I have a little table here. It says date, time, date and time. Now I'm going to show you a couple of functions here which are a really quick way of inputting today's date and today's time. And I'm going to show you a couple of different methods, one dynamic and one not. Now, if you want to put today's date into a cell, there is a formula to help us do that. And that formula is simply called today. Now, the today formula doesn't have any arguments, but we do still need to have an open bracket and a closed bracket on the end. Now, if I hit enter, it's going to show me today's date. Now, when you're using this formula, this is a dynamic formula, which means it's going to update according to your system time. So if I was to open this worksheet tomorrow, that date is going to have changed to tomorrow's date. Now, more often than not, that's super useful because it means you're not having to update it every single day. But there are occasions where you might want to hard code that date into a cell. So, for example, in the accounting industry, a lot of time there is a need to have a historical date in the spreadsheet. So we can still use the today function for that, but we need to use the keyboard shortcut as opposed to typing the function in. So if I want to hard code into the cell today's date, meaning it's never going to change, the keyboard shortcut is Control semicolon. Now I have similar functions for the time as well. So if I want to input into a cell the current time, which updates automatically, depending on the day and the current time, I would use the function called now. And again, this is a function that has no arguments. We can simply input it, and it's going to give us the date and the time. If I want to hard code the time into a spreadsheet so that it doesn't change, again, we can use a keyboard shortcut, Control Shift semicolon. Now, if I wanted to hard code both the date and the time into this spreadsheet, I can just combine those keyboard shortcuts. So I would enter the date, first of all, Control semicolon, space, and then the time, Control Shift semicolon, and hit enter. Now, what about if I wanted to change the formatting on these dates and times? For example, the date that we have at the top here. Currently, I have date formatting selected, and I'm using short date format. Now, we've already seen how we could change that to long date format if we wanted to, simply by selecting that option. But we do have more options underneath the Custom tab in Formatting. Now, to get to Custom, you can either click the drop down and go to More Number Formats at the bottom, or alternatively, you can click on the little diagonal arrow in the corner and go to the Number tab. And right at the bottom here, we have a Custom section. And this is really where you can customize the formatting that's applied to the cell. And you can really go to town here. Now, it's worth noting that these aren't just for dates and times. You can customize formatting for pretty much anything that you have in a cell, but there is a little group down here specifically related to dates and times. Now, if we click on this first one, you can see the format there is month, day, and year. And in the sample just above, it's going to show us how that's going to affect the value that we have in the selected cell. If I click on the one below, that's going to change it to a completely different format. So now we have 8 Jan 22. The next one down is just 8 Jan. The next one down, Jan 22. And you'll notice these are kind of set out as little pieces of code. So the D stands for the day, the M stands for the month, and the Y stands for the year. And how many of these you type in changes the format of this date. So if I decided I wanted this format where we have the word Jan, which equates to 3 M's, if I wanted that to say Jan 2022, I don't have a preset option for that, but I could change it up here. Now, because I just have 2 Y's, it's giving me the last 2 characters of the year. If I add another Y, take a look at what happens just above. I get the full year. If I add another one, if that makes more sense to you, it's going to stay the same thing. So you can completely customize how your formatting looks. Let's click on OK. I could do the same for the date and the time. Now, I think in this one, I'm just going to add the time. So let's just do Control-Shift, semicolon. So we just have the time in here. Now, my time is currently displaying as 11:38 p.m. But again, I could jump into Custom and I could use one of these time options down here. So if I want to display it in a 24-hour clock, I have an option for that. If I want to display the seconds, I can do that. So on and so forth. So I think I'm going to display it using the 24-hour clock and click on OK. Let's apply some more custom formats to our invoice tracker table below. Now I'm going to select all of these dates, and this time I'm going to click the drop down, more number formats, and let's go to custom. So what about if I want to display this date as 01/04/2020? Well, let me have a quick look through some of these. I don't think I have one that looks exactly as I want it to look. So what I'm going to do is I'm going to go up to this type field. I'm going to add in another M, see what that does. That's exactly right. 01 is displaying now. So if I go to D and add another D, I get the 04. And if I just wanted it to say 01/04/20, I could delete out 2 of these Ys and click on OK. And I've completely customized that formatting. Now, custom formatting can get a lot more complex than what we've done just there. But in terms of this intermediate course, that's pretty much all you're going to need to know at this stage. So jump into custom formatting, have a little play around with some dates and times, and really make sure you understand how you can modify the formatting so that your values look exactly the way you want them to look. In this lesson, we're going to blast through some of the most useful date and time functions in Excel. And we're pretty much going to cover most of the date and time functions that you're going to come across. So on this worksheet, we have a column A, that contains a date. And this date is currently in short date format. And we then have an invoice total. And what I want to do is I want to extract certain parts of this date into separate columns. And we're going to do this using date functions. Now, the majority of these that I'm going to show you rely on the fact that we have the full date in column A, because we're going to use this column as our reference point to extract the various different parts of this date. So effectively, we're breaking up this date into its different parts. And I'm going to show you a function in a moment that kind of does the opposite. So if you have things like the day number, the month number, and the year, how you can combine them all together into a short date format. But let's not get too far ahead of ourselves. Let's run through all of these different functions. So in column C, we want to extract the day number from the date in column A. So we have a function called day. Now notice there is only one argument for this, and that is serial number. And this is slightly misleading because what Excel means by a serial number is just the cell that contains the date. So in this case, A4. Close the bracket, hit enter. It's extracting the day part of this date. So in this case, 10. I can then double click, which is going to copy that formula down and extract the days for the rest of the date. Super easy. Now, what if I want to extract the day name from this date? And what I mean by the day name is Monday, Tuesday, Wednesday, Thursday, so on and so forth. Now, this works in a slightly different way, because if the answer that you want to extract from a date is a text-based answer, such as the day name or maybe the month name, you need to use the text formula. This function has 2 arguments, value and then format text. Now the value, again, is just the cell that we want to extract from. And then we need to provide the format for this day. So this is where those MMMs and DDDs come in again. So if we're extracting the day, we want to use the D, but how many Ds we use will determine if I get MON, M-O-N, or Monday. And this needs to go in quote marks because it is essentially text. Now if I type in 3Ds first of all and close my quotes and hit enter, I'm going to get the short version of the day name. Let's double click to edit. If I was to add another D in here and hit enter, I get the long day name. And then I can double click to copy that down. So just remember that when you're trying to extract things from dates, if it's text, you need to use the text function. Let's move across to the next column because this time we want to extract the month number. And for this, we use the month function. Again, one argument, which is the serial number, A4, close the bracket, hit enter, and we get the month number part of this date. Now, once again, the next thing that we're extracting is the month name. So this is going to be January, February, March, and this is text. So we need to use the text function again. Let's select our value, which is A4, and then we can choose our format, which needs to go in quote marks. So this time we're dealing with the month, so we want M's in here. If I do 3 M's, I'm going to get the short version of the month, so Jan, Feb, Mar. If I put 4 M's, I'm going to get the long version of the month. Let's hit enter, and then of course I can double click to copy that down. Really straightforward. The next one is super easy. We're extracting the year, and we have a year function. You guessed it, serial number, close the bracket, hit enter, and it's going to extract the year part of that date. And then finally, I can extract the weekday number. And we can do that using the weekday function. Now the first argument here is the serial number, so we need the date again. And now we can specify how we number our weekdays. Now I tend to number mine as in Monday is 1 all the way through to Sunday being 7. But some people in different parts of the world number their weekdays differently. Some people might start their week on a Sunday, and so that is number 1 to them. Some people might start on a Thursday, so on and so forth. And this is the argument where you can specify exactly that. So if I choose to put a 2 in here as this argument, it's going to number Monday as 1 through to Sunday 7. And that is exactly what I want. Close the bracket, hit enter, and now I get the weekday number. Double click. So if I just take a quick look at this, this first one is 4, and yes, Thursday, according to me, is day number 4. And if I wanted to get super fancy, and this will even give us a chance to practice a quick if statement, I could type in an if statement here which tells me if this date effectively in column A is a weekend or a weekday. So what I could say here is equals if my logical test. Well, what I can say is if the weekday is greater than 5, if that is true, then yes, it's the weekend. If it's not, then no, it isn't. Because Saturday and Sunday are effectively numbered 6 and 7. So if I hit enter and then copy this down, I should find that most of these are no, except when we get to anything that is a 6 or a 7, which will be yes, because these represent Saturday and Sunday. So some really useful functions in there. Now I mentioned earlier that we can in fact do the reverse of that and combine values together to create a date. So if we take a look at this table at the top here, you can see I have the year in one column, the month in another column, and the day in another column. So what I can do here is use the date function. And all I need to do is specify the cell. So the year is cell K4, the month is L4, and the day is M4. Close the bracket, hit enter, and I get that date, which I can double click and copy down. I could do exactly the same for time. So equals time. We need to specify the hour, the minute, and the seconds. Close bracket, hit enter, and there I get my times. Super useful functions. Now let's jump across to the time functions worksheet, because I just want to finish off by showing you how we can do pretty much exactly the same, but this time using time as our serial number. So I have some times in this first column, and we can break those down using more functions in Excel. So the first one is the hour function. Again, it just requires a serial number, and it's going to pull out of that the hour. Double click to copy down. We have a minute function. Again, serial number is required, and we can double click to copy that down. And then finally, we can add the seconds by using the second function. Serial number, close the bracket, hit enter, and then we can double click to copy that down. Now, because of the way that I have these times, these last two are just showing zeros, and that is actually correct. It's really only this first column that has different values in it. In this lesson, we're going to take a look at a couple of really quick little formulas that can be super useful. And that is the Workday function and the WORKDAYS.INT function. So let's start out with the WORKDAYS function. Now in the table at the top here, I have a list of tasks that need to be completed. And I also have the start date of those tasks. So maybe this is some kind of basis for a project plan. And in column C, I've listed out the number of work days that each of these tasks is going to take. Now, when I say work days, I mean Monday to Friday, so excluding the weekends. And what I want to work out is the finish date based on the work days and the start date. So the work days formula will basically calculate 5 days after the start date, but it won't include any weekends in that calculation. So let's go to finish date. We're going to type in equals, and we're going to use the workday function. Now we have 3 arguments here: start date, days, and then we have an optional argument of holidays. Because what you can also do in here is get the formula to exclude holiday days as well. So those might be public holidays, Christmas Day, New Year's Day, Easter Monday, things like that. Now, in order to include the holidays, you need to have the holidays listed out somewhere. So you can see that I have all of the holidays in the UK listed out in a little table. So the first argument here is the start date. So I have that listed in cell B4, comma, days. So how many days is this task going to take? Well, this task is going to take 5 days. Now I could leave it just there. I could close the bracket and hit enter, and it's going to give me my finish date excluding weekends. However, if I wanted to include holiday days as well, let's double click to edit, comma, I can then select the holiday dates. So that is this little range just here. Hit enter, and then I can copy this formula down, and I have my finish dates. So that is how the WORKDAYS function works. Now what about the WORKDAYS.INT function? Well, let's delete out our finish date just here and take a look at WORKDAYS.INT. And it's this one just here, WORKDAY.INT L. Let's double click. Now this is pretty much the same, but it takes into account international weekends and holidays. So the first argument is start date, so B4, that's nice and easy. Number of days, well, that is 5, comma. Now the third argument is weekend. So if you have weekends that start on a different day, so maybe your weekend isn't Saturday and Sunday in your location. I know in the Middle East and other places, Sunday and Monday tend to be the weekend. You can account for that by selecting different days for your weekend. So let's just do Sunday and Monday for a change. And then if I want to add in holidays, I can do that as well. So I might want to use these holiday dates again, close the bracket and hit enter, and then I can copy that formula down. Once again, I'm going to get that little error because I'm not using all of the data. So let's do ignore error. So that's the difference between Workdays and Workdays International. In the previous lesson, we saw how we could return a finish date using the Workday and Workday International functions when we have a start date and the number of work days. Now in this lesson, we're basically going to do something very similar using two different functions, Network Days and Network Days International. Now this is very similar, except we start with a start date and also an end date, and these formulas work out the number of days it's going to take to complete the task. So in the table underneath, again, we have some task names just here. We have the start date for that task, the end date for that task, and I want to know how many days it's going to take to complete this task. So how many days between these two dates effectively. And again, these two formulas will exclude the weekends and any holidays if you specify them. So let's start out with network days. These are very straightforward formulas. There it is. We have three arguments again. This time we have the start date, which is B18, comma. We need our end date, which we have in C18. And again, we have that optional argument on the end to include holidays. Now I'm going to select all of these here, and something I didn't actually do in the last lesson when I did this is I really need to lock these cell references in place because I am going to drag this formula down and I don't want this range moving. So I did forget to do that last time, so if you spotted that, well done. Let's press the F4 key to lock those in place, close the bracket and hit enter. Now notice I have something weird in here. If I double click to copy down, I have some dates in here in 1900, which is odd. Now why am I getting that? Well, if we take a look up at the Home tab, it's because I accidentally applied date formatting to these cells. So all I need to do is switch this back to General, and then I get the actual numbers. And Network Days International is pretty much the same, but again, this accounts for people in other locations. So let's select this. Again, we need a start date, comma, we need our end date, and then we can specify our weekend days. So again, if you're in a different location where your weekend days are not Saturday and Sunday, you can just choose those from this list. And then if you want to, you can add in your holiday days, F4, let's remember to lock, close the bracket, hit enter, and then I can copy those down. So again, two super simple but really useful functions that everybody needs to know. The DATEDIF function in Excel will help you work out the difference between two dates. And this is a little bit of a weird function, and I'll explain to you why in a moment. Before we get on to that, let's take a look at the data. So in this table, I have some employee numbers. I have the employee's first name, their last name, and their date of birth. And what I want to do is I want to work out how old they are. So what is their age based off of their date of birth, but also using today's date. So at the top of the spreadsheet, I have today's date, and I'm using the today function to get that date. Now in this type of scenario, it's going to be more beneficial for me to use the function today as opposed to hard coding today's date in, because I want this age to update as the current day changes. And it's this piece of information, today's date and the date of birth, that we need in order to construct this formula. Now, as I mentioned, this is a bit of a strange formula, and you'll notice why straight away. So if we type equals, and then we want to type in DATEDIF, notice that nothing comes up underneath. Normally, when I type in a function, Excel recognizes it in the functions library, and it shows me underneath. For example, if I was typing in VLOOKUP, you can see underneath it says VLOOKUP, whereas when we do DATEDIF, it doesn't. It also means I can't press the tab key to put my first parentheses in. I need to add in the bracket. Now, as soon as I add that in, it does come up with DATEDIF underneath, but it doesn't show me any arguments. So basically, this function doesn't exist in Excel's information library, although the function does exist, which is very, very strange. So effectively, when we're constructing this, it's one of those cases where you either know or you don't, because you're not going to get any help with regards to the arguments you need to provide this function. Now, fortunately, this is a very simple function. Our first argument is going to be the date of birth, which is D6, comma. Our second argument is going to be today's date, so B3. And now we need to tell the formula what format we want to display this result in. Now, my result, I want the people's ages. So effectively, I want this in year format. So in quote marks, if I type in 1Y and close the quotes, that is my formula. Let's hit enter and see what we get. Looks pretty good. Now, can I double click to copy this down? No, I cannot. Why can't I do that? Let's undo. Well, if I double click to take a look at this formula, you can see here that with cell B3, which is where we have the today function, I haven't made this absolute. So when I copy this formula down, the cell reference for B3 is also going to start moving down into these first names. So that is why we're getting an error. So all I really need to do here is make B3 absolute by pressing the F4 key. Let's hit enter and try that again. Double click to copy down. And there we go. I now have everybody's ages in here. So just remember with that function, you don't get any help with regards to arguments. And the thing that I find quite difficult here, it's not too bad on this example, but sometimes when I'm trying to use DATEDIF, I tend to get the cell references round the wrong way. I can never really remember if the date of birth is supposed to go first or if today's date is supposed to go first, but the only thing I can suggest to you there is just try it out. If it doesn't work, switch them around the other way. Now, another thing, if I double click to edit this, if I wanted to show their age in months, I don't know why I'd want to do that, but if I did, I would just substitute the Y for an M and hit enter, and it's going to show me their age in months. So MacBerry is effectively 216 months old. If I wanted to show their age in days, I would substitute that with a D, and there we go. Mac is 6,580 days old. So don't forget that you can change the format from here as well. Now for this type of calculation, there is another way you can do this, so I'll just finish off by showing you this as well, because you might find it a bit easier. Let's Control-Shift down arrow and delete everything out. What I could do is sometimes you don't even need to use a formula if you want to work out the difference between two dates. So what I could do is today's date minus the date of birth. Now notice that's going to give me my result in days. So what else would I need to do to this formula to get this to display as years? Well, I could divide it by 365. Now, if I just do divided by 365, because of the way Excel works out calculations, that's not going to be quite correct. So what I need to do here is I need to enclose the first part of this formula in brackets. So Excel is going to do the B3 minus D6 first of all, and then it's going to divide the result by 365. And what I also need to do is lock the cell reference for today's date. Let's hit enter. We can double click to copy those down, and then all I need to do is just have a little play around with the formatting. So I'm going to switch these to a number and then take those decimal places down, which is going to give me the same result. So two different ways there that you can work out the difference between two dates. Two other functions in Excel that can be super useful when you're trying to calculate dates are EOMONTH and EDATE. So let's take a look at EOMONTH first of all. Now, EOMONTH basically stands for end of month. And in this example on the screen, what I basically have here is a loan amortization schedule. Now, don't worry too much if you're not sure what this is. We are actually going to look in great detail at how we put together one of these a bit later on in this course. But basically what this does is it works out the monthly payments for a loan. That's not particularly important in this example, but using the EOMONTH function to work out the payment date is. So if we take a look at this table, this is basically our schedule table. And what this tells me is how much I'm going to be paying each month, how much of that payment is going to be interest, how much the principal loan, the loan amount effectively, is being reduced by, and then the ending balance. And what I want to add in here are the payment numbers and also the payment date. And this loan is going to be paid on the last day of every single month. Now, as we're doing this, I just want to show you a couple of other little bonus tricks as well. If I take a look at the table above, over the course of this loan, we're going to be making 360 payments. So effectively, this is a 30-year loan. So what I want in the payment number is I want numbers 0 to 360 listed out here. Now I could go through and start typing in 0, 1, 2, but that's obviously going to take me a long time. There are other ways I could do this. I could type in the first few, so 1, 2, 3. I can select them all and then I can drag those down, but still dragging down to 360 is a little bit tedious. So a little trick that you might want to use if you need to get a lot of numbers into a spreadsheet. Let's type in the first one. I'm going to press Control Enter to stay in the same cell. And what I'm going to do is grab the little fill handle in the corner and using the right mouse click button, I'm going to click, drag down a cell, drag back up a cell and let go, and it opens up this secret menu. And if I click Series, I can then select Columns and then choose my step value. So we're going to step 1 each time, and my stop value is 360. When I click on OK, take a look at that. If I do Control down arrow, notice it's input all those numbers all the way down to 360. So that's a really neat little trick. Now what I want to do is I want to enter in the dates for each of these payments. Now again, if we look at the table at the top, the start date of the loan is October the 31st, 2021. So let's put that in as our first payment date. So we want 10/31/2021. Now if I want to fill all of these down, if I was to drag this date down, notice what it does. It goes to the next day. So we have October the 31st, then November the 1st, November the 2nd, November the 3rd, so on and so forth. Now, I don't want it to do that. What I want is for it to input the last day of the month. So one of the ways that I could do this is to use the function EOMONTH. So let's type in equals EOMONTH. The first thing we need to specify is a start date. Now, I'm just going to use this one up in the table. D12, and because I'm going to drag this down, I don't want this to move, so let's lock it. Now this little screen tip is in the way, so we can just drag that down. I now need to specify the month that I want to pull the end date from. Now if I was to put a 0 in here and close the bracket and hit enter, it's going to give me October the 31st. Now I don't want that. I want this one to be the end of November. So let's double click and let's adjust what we have on the end here. Let's change that to a 1, and there we go. That's what I get. So if you wanted to input the last day of the current month, you would use a 0. If you wanted to input the last day of the next month, you would use 1, so on and so forth. Now what happens if I try and drag this down? It doesn't work. Now why is that? Well, if we double click to take a look at this formula, it's because I'm using the date up here in the table and I've locked it. So it's always referring back to this date. So really what I should probably do here is if we delete that out, I'm going to use the date above and hit enter. And now if I double click to copy that down, I should get the last date in every single month. And if we take a look at February, it's picked up that February only has 28 days, and it's also worth noting that if this is a leap year, Excel does recognise leap years and will have the 29th in there instead. So EOMONTH, a really good formula for just listing out the last day of every month. Let's move across to the EDATE worksheet. Now this is kind of similar. This is where you can start with a date and then you can return a date, a specified number of months before or after that date. So let's click in the cell and type in EDATE. whoops, like so. 2 arguments, start date and months. So start date is going to be A5, number of months. Well, if I put 2 in here and close the bracket, notice it gives me a number, and that's because I don't have these cells formatted as dates. So let's deal with that straight away. Let's jump up to here and change these to short date. And would you look at that? It's now giving me a date that is 2 months ahead of the start date. Let's do it again. EDATE, start date, comma, how many months? This time we want 3, close the bracket, hit enter. If I want 10, you get the idea. Start date, 10. Now what about if I want to go back? Well, we can do pretty much the same thing. So we want EDATE, then we want the start date. And what I can say here is -1. Close the bracket, hit enter, and I get the month before. Let's do it one more time. EDATE, start date, and this time we're going back 4 months and hit enter. And then of course I can grab all of these formulas in one go and copy them down. It's time now to do exercise 4. And in this exercise, I just want you to practice some of those super useful date and time formulas. So we have a date in column A, and using this date, I'd like you to complete the rest of these fields. So I want you to extract from this date the month, the day, the year, the weekday number, the weekday name, the month name, and then finally I'd like you to add a formula into column H which checks if the day is a Friday. And if it is a Friday, we want the output to be yes. If it isn't a Friday, we want the output to be no. The other thing to remember with this is that if the result that you want returned is text, for example, the weekday name, remember you need to use a slightly different formula. Now's the time to pause the video and give that a go. If you'd like to see my answer, then please keep watching. So the first thing we're going to do here is we're going to extract the month from the date that we have in column A. So for this, we use the very simple month function. It only has one argument, and that is the cell that contains the date, in this case A4. Close the bracket, hit enter, and it's extracted the number 2 from this date. This time we want to extract the day. So for this, we can use the day function. Again, one simple argument. Close the bracket, hit enter. And as you can imagine, we can also extract the year. We can select A4, close the bracket, and hit enter. Now for the next one, we want to extract the weekday number. So we're going to use the function called weekday. Again, we need to select the serial number, so the cell that contains the date. And then we need to tell Excel how we number our days of the week. So if you number 1 to 7, Sunday through Saturday, you're going to select the first option. Now, I generally tend to number my weeks as Monday is 1, Sunday is 7. So I'm going to go for option 2. Close the bracket, hit enter, and now I get my weekday number. Now for the next 2, we want to return the weekday name, so if it's Monday, Tuesday, Wednesday, and also the month name as well, January, February, March. Now because we want text to be returned, we need to use the text function. Our first argument is the value, so that's going to be the cell that contains the date. And then we need to specify the formula. So this one is going to be the weekday name. Now I want this to show in the short weekday format. So I'm going to open up quote marks and type in 3 Ds. Close those quote marks, close the bracket, hit enter, and now I get my weekday name. I need to do something very similar if I want to extract the month name as well. So we're going to start with the text function. The value is our date, and then we specify the format that we want our month to be in. So once again, I'm going to do the short date format, so MMM, quote marks, close the bracket, hit enter. And then the final thing I wanted you to do in column H is work out if this day is a Friday. And how can we do that? Well, we can use the weekday number. Because I've numbered my weekdays 1 to 7, I know that Friday equals 5. So all I need to do in here is add in an if formula. So if the weekday number is equal to 5, if that's true, then yes, it is a Friday. So our result is going to be yes. If that's false, then no, it's not Friday. Close the bracket, hit enter. And you can see that for that first one, it is a Friday, and so we have yes in there. So now I have all of these formulas. If I want to copy them down for the rest of this table, I can simply select them all and double click to copy those down. In this section of the course, we're going to explore some of the techniques we can use to prepare our data for analysis. Now, Excel is well known for its data analysis tools, so things like pivot tables and charts and different types of calculations and formulas. But what's lesser known is how important it is to make sure that the data that you're going to analyze is clean and in an appropriate state. Because many times, data that we're using isn't necessarily a data set that we've created. So it might be that you've received a data set from a client or a colleague, or maybe you've even downloaded data from an external system or some third-party software. And as we all know, we don't live in a perfect world, so it might be that when you've done that download, the data that comes into Excel isn't in the best format for analyzing. It might be that you have blank cells or blank rows everywhere. Maybe there's weird formatting or inconsistent case. Maybe there's spelling errors or duplicate values. All of these things need to be dealt with before you start to create things like pivot tables and pivot charts. And that is what we're going to look at in this section. I'm going to show you lots of different techniques when it comes to cleaning data. So in this first lesson, we need to get some data first of all. And this is going to give me an opportunity to show you a couple of other techniques when it comes to importing data. So what we're going to do here is we're going to import a data set first from a folder that contains numerous Excel files, and then we're going to import a text file. Now for this, we need to start with a blank document. So I'm going to use the shortcut key of Control-N to create a new blank workbook. Now to import data into Excel, we need to go to the Data tab. And it's this first group here, the Get and Transform Data. And this little group tends to change in every new release of Excel. They usually change the wording and where they have things positioned in this little area. But this is how it looks right now in Excel 2021. Now notice in here we have a few different buttons which will allow us to quickly import data from a text or CSV file, from the web, from another table or range of cells. We can go to recent sources or look at existing connections. We also have a Get Data drop-down over here, which gives us access to all these different sources to import data from. And you can see there are so many. So you can do things like import data from a SharePoint list, or maybe you want to import something from Microsoft Exchange, or even an external application like Salesforce. Maybe you want to import something from an Access database or an Oracle database. Or maybe you just want to import from a different file. That might be an Excel file, a text file, maybe a PDF, or even from a folder. So lots of different sources that we can import data into Excel from. Now before we get to this point, let me show you the files that we're going to import. And you'll find these to download in the Course Files folder. Now in the Course Files, I have a folder here called Sales Data. And if I double click to open this folder, I have in here 4 files that are all exactly the same. They just contain sales data for different years. But if I was to open each one, they have the same format. So they all have the same column headings, they just contain different sales data for each of the years. Now, because these files are pretty much identical in their layout, it means that I can import them and combine them all in one go. So instead of having 4 separate files for the 2016, 2017 and 2019 data, what I can say to Excel on the import is import all 4 of these from the folder and combine them together into one big long file. So let's go back to Excel. Let's go to Get Data from File, and because I have these stored in a folder, I can choose to import them from the folder. Let's select the folder. I don't need to drill down into it. I just need to select the folder that contains the files and click on Open. Now what Excel will do here is it's going to take you into Power Query. And you may not be all that familiar with Power Query, or you might have used it briefly. We're not going to go too far into Power Query because it is more of an advanced topic, but I am going to show you a couple of small things that you can do here. So what Excel has done is it's picked up those 4 files and you can see them sitting here. So Sales 2016 to Sales 2019. And then at the bottom, I have a few different options with regards to what I can do with these files. Now I can choose to combine them at this stage. I can simply load them straight into Excel, or I can transform the data. Now transforming the data will open these files in Power Query and will give you access to all of Power Query's tools for cleaning data. Now the focus of this section of the course isn't to learn how to clean data in Power Query, it's to learn how to clean data in Excel. However, let's click Transform Data so you can see what this looks like. So basically, I'm now in the Power Query editor. And as I said, don't worry too much about what you see on here. The only thing I really want to show you here is how you can use Power Query to combine these 4 files together. So currently, there's still 4 separate files. What I can do here is click these 2 drop-down arrows, and when I hover over it, it says Combine Files. It's going to give me a preview as to what the first file looks like. And if I click on OK, it's going to combine those files together and load the data into the Power Query window. So now I basically have a big long list of all of those files instead of 4 separate files. Now that I've done that, I can load it into Excel and start to clean it. So I have a Close and Load button at the top here. And what this does is it basically creates a connection between that folder and Excel. So if maybe at the end of the year, I then get a file called Sales 2020, in order to update this Excel spreadsheet, all I would need to do would be to copy the Sales 2020 file to that sales data folder. Because we're connected to the folder, the connection will update and automatically include all the 2020 data in this file. So that is why this method can be pretty useful. Now I'm going to close down the queries and connections because once it's been imported, notice that it's automatically been placed in a table. How do I know that? Well, I have the table design ribbon at the top and I have a table name called sales data, which now includes all 4 of those files. Now there might be a couple of things I want to do here to tidy up this data. For example, I don't really need column A, which is just basically listing the file name. So I'm probably going to delete out that column. I might want to apply some formatting to these columns, so Control-Shift down arrow. And let's go to Home and apply some currency formatting. And there might be some other bits and bobs that I want to do here. So that is one way that I can import a folder of files into Excel. Now you don't necessarily have to always import a folder. If you just had one Excel file, you could go from File, from Workbook, and then you can just select the file that you want to import. Now what we're actually going to do, and this next file is the file that we're actually going to be cleaning up, is we want to import a text file. And again, you're going to find this file in the Course Files folder. So if we go up to the Data tab, again in this Get and Transform Data group, I have a From Text CSV button. So let's click. And it's this file here that we want to import salesdata.txt. Now this is going to open a preview of this text file. I have the option of opening this in Power Query and cleaning it up in that application by clicking the Transform Data button, but this time I'm simply going to load it straight into Excel and clean it there. So let's click on the Load button. And there we go. So once again, it's loaded this data in and it's created a table automatically out of this data. And it's this data set that we're going to take the time to clean up, because notice there are a few different issues going on in here. Now, to make this a bit easier to see, I'm going to go to Table Design and just turn off banded rows so we can see these issues a little bit clearer. Now, I can see that in this spreadsheet, I have a couple of blank rows in here, which I need to get rid of. I can also see in column B, I have some inconsistent casing issues going on, and I also have some weird spacing at the front of these words. I can see that many of these columns haven't got the correct formatting applied, and there might well be duplicates lurking around in here as well. So all of these are things that we need to consider when we're cleaning our data sets. So we're going to start out with this data set in the next lesson, and I'm going to show you how you can quickly remove all blank rows and even blank cells from your worksheet. In the previous lesson, we saw how we can import a folder of files and also a text file into Excel. And it's this text file that we're going to clean up and prepare for analysis. Now, if you find that when you are opening these files, you get this security warning running across the top in yellow, then you can simply click Enable Content. It's just because we've created external links when we've imported this data. So I'm going to click Enable Content, and I'm going to say, do not ask me again for network files. So now we have this data set, and the first thing we're going to deal with here are these blank rows. I'm also going to show you how to handle blank cells and how to remove duplicate entries. So let's start with the blank rows first of all. Now, blank rows in general can cause problems when you're analyzing your data. For example, if I want to put this data into a pivot table and then start creating things like charts, if I have blank rows in there, it's going to throw off my data. So you always want to make sure that you remove any blank rows that you have in your data set. Now, if you have a very large data set and you have quite a lot of blank rows in there, it's going to be pretty tedious to go through and try and delete all of these manually. So I might decide I want to select these two rows, hold down Control, select these two, scroll down, select some more. That's not particularly time efficient. Fortunately, there is a quick way to do this in Excel. So all we need to do here is click somewhere in our data, go up to the Home tab, and then all the way over in the Editing group, if we go to Find and Select, and then go to Special. And this is going to open this little Go to Special dialog box. Now, if you're interested in keyboard shortcuts, there isn't a keyboard shortcut to go directly to Go to Special, but what you could do is press Ctrl G and then click the Special button. Now, what this allows you to do, amongst other things, is select different items within your spreadsheet. And one of the options that we have here is to select all blanks. So let's select that, click on OK, and it highlights all of those blank rows. So now with them all highlighted, I can go up to that Home tab again, into the Cells group, and using the Delete drop-down, I can delete sheet rows, and I've deleted all of them in one go. So that's going to save me a lot of time. Now, another thing you want to make sure you deal with in your spreadsheets are blank cells. Now, I don't have any blank cells, but if I did, let's just delete a few things out of some of these cells. Let's go like that, like so. Now again, blank cells can cause a bit of a problem. It's always better to have some kind of numeric value in these cells, even if that is just a 0. So once again, if I want to select all blank cells in this particular column, all I would need to do is select the column, Ctrl G, Special, and I can select blanks and click on OK. And that will select all of the blank cells just in the range that I've specified. So now I can enter a 0 into all of them in one go. So all I need to do here is type 0 Control, Enter. And that's going to put a 0 in all of those blank cells. I haven't had to scroll through and do them all individually. So again, that is a real time saver of a trick. And the final thing I want to show you here is removing duplicates from your data set. So it might be when you import your data in, some duplicates come across for whatever reason. Now, when I say duplicates, I mean an exact duplicate of every single column in this row. Now, it's always worth removing duplicates, even if you're not sure if you have duplicates in your spreadsheet. And in Excel, we have a button that can check duplicates for us and remove them quickly. So let's make sure we're clicked somewhere in our spreadsheet, up to the Data tab. And in the Data Tools group, we have a Remove Duplicates button. Now, when I click this, it's going to ask me to determine what is actually a duplicate. And the first thing I need to make sure that I select is my data has headers. And notice it's picked up all of the different columns and it's put a tick in the box next to all of them. So what this basically means is that every column has to be the same for it to be considered a duplicate. Now, I'm happy with that because I only want to remove duplicates where every value in the row is duplicated. So let's click on OK. You can see that it's actually found 2 duplicate rows or values and it's removed them. Click on OK and we are done. So that is how you can very quickly delete blank rows, input data into blank cells, and also remove duplicates. In this lesson, we're going to continue cleaning our sales spreadsheets, and I'm going to show you how you can use text functions to help you fix some of the errors that we have in column B. Now, if we take a closer look at column B, the product column, what do you think is wrong with this column? Well, if you said the text inside this column is inconsistent, you would be correct. If you notice that some of the words in this column are in uppercase, some of them are in lowercase, such as Royal Oak in cell B8, and some of them are in what we call proper case. And proper case just means that the first letters of each word are capitalized. Now, proper case is how I want everything to look in this column. But what I don't want to do is have to go through each and every row, changing all of these words to proper case. Something else that's wrong in this column is that I can see I have some weird spacing. And this is something which can easily be missed. I think it's just because I've spent many years staring at Excel spreadsheets, I have a really keen eye as to how far away from the edge of the cell text should be. And I can see that in column B, if we take a look at the word Kensington, the gap between the first letter and the edge of the cell is actually a bit wider than it normally is. If you compare that to column A, Japan is a lot closer than Kensington is. So I know that I have some kind of space at the start of this cell. I can also see that for some of these, I have double spaces in between the words also. And it might be that I have trailing spaces after these words that I can't even see. Now, why is that a problem? Well, again, if I was going to put this information into some kind of pivot table, or even if I was to use a filter, it could mean that that is listed twice in the filter as opposed to once. It also could throw up some unexpected results when we're putting together our pivot table. So what I'm trying to say here is it's always best to make your data consistent across your spreadsheet. So we're going to spend this lesson tidying up column B using text functions. Now, before we start working on this column, what I'm actually going to do, just to make this super easy to understand, is I'm going to take this data out of this table, because this table was automatically created when I imported this text file. Now, if you want to remove data from a table, all you need to do is jump up to Table Design, and in the Tools group, select Convert to Range. Click on OK, and now the data is no longer in a table. Notice that when I'm clicked in this data, I no longer get the Table Design contextual ribbon. So now I just have bog standard data. I'm going to insert a new column, and I'm going to use the keyboard shortcut Control-Shift+. Now, this is what I'm going to call, for now, my helper column. And I'm going to use this column to tidy up the text that we have in column B. So the first thing that I want to do here is I want to change everything to proper case. So the function that we need to use for that is, as you might expect, a function called proper. And this is one of the text functions in Excel. There's only one argument for this particular function. So that is the text that we want to change to proper case, B2. Control Enter to stay in the same cell, and then I can double click to copy that down. And like magic, all of my text is now consistent. It's also worth noting that if you wanted to change everything to uppercase, you could replace proper with upper. And if you wanted to change everything to lowercase, you guessed it, you can just replace it with lower. So 3 really helpful little functions just there. Now it's changed everything to proper case, but what it hasn't done is remove these weird spacing issues that I have going on. Now if you want to remove what we call erroneous spaces from a text string, we use the trim command. So what I'm going to do here, Control Shift down, let's delete everything out, and let's take a look at the trim function on its own. So equals trim. Again, it just requires the text that we want to trim. Now, can you see the difference there? If I drag this down a few, Kensington, now that we've trimmed those spaces, is a lot closer to the edge of the cell boundary than it is over here. So those spaces at the beginning have been removed simply by using that trim function. It's also worth noting that there is another text function called clean, which will remove things like manual line breaks and non-printing characters. So for example, if I had a line break in between these two words, let's put in a manual line break, Alt Enter. If I wanted to remove that line break, I would use the clean function. Again, we just have one argument. Let's hit Enter. And we should notice this when we go past Royal Oak. And yes, now you can see that Royal Oak is all on the same line. It's removed that line break. Now I'm just going to undo a few just to get rid of that line break. So we have 3 functions there, proper, trim and clean. Now I want to apply all 3 to column B. So what I can do is I can combine them all together. We're going to start with proper, we're going to open a bracket, we're going to go straight into trim, we're going to open a bracket, we're going to go straight into clean and open a bracket. We then just need to select the text that we want to apply all of this to, and then we need to close off as many brackets as we've opened. So close off clean, close off trim, close off proper, hit Enter. And then I can double click to copy that down, and I've applied 3 text cleaning functions all in one go. And it looks absolutely beautiful. So now I have a clean column, column C, and I have what I'm going to label, for want of a better term, a dirty column in column B. Now you might think that you can just go in here and right click and delete column B. But if you do that, you're going to get these reference errors because we have formulas in column C that refer to column B. So if we delete that column, it effectively breaks that formula. So how can we keep the text that we have in here, but just remove those underlying formulas? Well, what we can do is we can use Paste Special to help us do that. So what I'm going to do is I'm going to select column C, the column that contains the formulas, Control C to copy. I'm going to go to the Home tab, go to Paste, and I'm going to say Paste Values, and I'm going to paste just the cell values directly over the top. And what that does is it just keeps the text that you can see, and it throws away the underlying formulas. So now that I've done that, I can simply delete the dirty column, and I'm not going to get any errors. I need to change this column heading as well, so this needs to be product again, but that is a nice clean column. So I would apply that type of thing to any column that I can see has issues. For example, I think all of these are pretty much okay, apart from this month name column. I can see that that has what we call erroneous spaces at the beginning there as well. So I'm going to do the same thing. Let's insert a column. This time I'm just going to do a trim. Let's select the text, Control Enter, and then I can double click to copy down. I want to throw away the underlying formulas, so Control C to copy, paste, and paste values, escape, and then I can simply move this heading across and then delete column L. And whilst we're here, I'm going to apply some number formatting to columns which don't have it. So I can see here that manufacturing price, sales price, all of this to here needs to have accounting format applied. So Control Shift down arrow to select all of those cells, and let's click on accounting, and there we go. So we're now ready to move on to our next stage of cleaning. In the next couple of lessons, I'm going to show you some techniques for splitting up information. And in this first lesson, the method that we're going to use is splitting up data using text to columns. Now, what do I mean by splitting up data, and why is this useful when you're cleaning your data? Well, let's take a look at a very simple example first of all, and then I'll show you how you can use that on the sales spreadsheet that we've been working on. Now, on this first example, if you take a look, I've got some information listed in column A. And this might be information that I've imported from something like a text file. And you can see here, it basically shows the employee name. We then have a comma, which we call the delimiter. We then have that person's job title, then a comma, then the department that they work in, then a comma, and then their salary. And this is a very realistic example of what data actually looks like if you import it from a text file and don't break it up first. So it's a very real possibility that you might import data and it does look something like this. Now, what we basically want to do is we want to break up the data that we have in these cells so that we have the employee name in one column, job title in another, department, and salary. And there are a few different ways that we can do this type of thing. Now, we're going to use the oldest method in Excel first of all, and that is by using text to columns. So what I'm going to do is I'm going to select the data that I want to split up. Let's jump up to the data ribbon, and in the data tools group we have a big old button here that says text to columns. And the screen tip says split a single column of text into multiple columns. And that is exactly what I want to do. So let's click on this button. Now this is going to basically take you through a convert text to columns wizard. And if you've ever used a wizard before, you'll know that it kind of guides you through the process. Now the first thing we need to determine here is if our column is delimited or fixed width. Now, delimited means that your different fields, so your different items, the employee, the department, the job title, so on and so forth, how they are split up. So the delimiter that I'm using here is a comma. I have a comma separating each of my fields. So I'm going to choose delimited and click on Next. On the next page, this is where I can define the type of delimiter I'm using. Because it might be that your fields are separated with a tab, or maybe a comma, or maybe a semicolon, or a space, or maybe some other item entirely. Now, if you do have your fields separated with something that you can't see listed just here, you can choose Other and then specify in here how your fields are separated. Now mine is separated with a comma, so let's choose that option. And as soon as I do that, you can see in the preview window, it's now splitting my data wherever it finds a comma. So that is absolutely perfect. Let's click on Next. Now here, if I wanted to, I could start applying some formatting to the columns. Now I'm just going to leave my columns on the default, which is general. The important thing here is the destination. So this is where you specify where you want your data to be placed after it's been split up. So I'm going to remove A4 from there because I want the first item to be in cell C4. Let's click on Finish. And would you take a look at that very quickly? It's broken everything up into nice, neat columns. And I can then just go in and do my final pieces of formatting. So that is a very simple example of how you can use text to columns to break up data into multiple columns. So now let's take a look at how we might use that on the sales data that we've been working on. So on the next tab, I've actually made a small change to this worksheet just so I can show you this example. Now, if we take a look in column A, what I've actually done here is I've combined the country with the product, and the product is listed after the country in brackets or parentheses. So what I want to do here is I want to split up the country and the product into two separate columns. So for this, I need to add two blank columns. So Control Shift plus, Control Shift plus. And let's call this one country and this one product. So now I can use text to columns to break up this data. So the first thing I'm going to do here is Control Shift down to select all of the data. Let's go up to the Data tab and select Text to Columns. Once again, this is going to be delimited, but this is a bit different to how it was previously. Because what is separating my two fields? What is separating the country and the product? Well, I have a bracket in there. So I'm going to say that I want to split my data where it finds that first bracket. Now, if you take a look at the data preview, that's fine. I've got the country in one column. I have the product in the next column, but I have a trailing bracket. Now, we're going to deal with that afterwards. Let's just get this split up first of all. So let's click on Next, and my destination, let's remove that, is going to be cell B2. Now, it might be that you get this error that says there's already data here. Now, I don't have any data there. Let's click on OK, and it's still going to put that in. So now what I can do is I can basically delete out this first column. Now, the final thing we need to deal with here is this trailing bracket that we have in this column. We don't need that to be there. So I can get rid of this doing a simple find and replace. And what that will do is it will allow you to specify what you want to find, in this case a closing bracket, and you can say what you want to replace it with. And I'm going to replace it with a blank, which will effectively remove it. So I'm going to select column B and press Control F. Now I'm going to jump across to the Replace tab and I'm going to specify what it needs to find. So I'm looking for a closing bracket and I want to replace it with nothing. So I'm going to leave this blank and replace all. It's made 702 replacements and it's got rid of that closing bracket. So that is how I could use text to columns in a more practical example. In the next lesson, I'm going to show you how you can do the same thing, how you can split up data, but this time using Excel functions. In this lesson, I'm going to show you how you can split up data using text functions. And if we jump across to the Formulas tab and take a look in the text group in our functions library, this is where you're going to find all of the commands that I'm going to be using. And you can see we have so many different text functions in here. Now, I will say that for certain pieces of text, using text functions is a pretty easy endeavor, but sometimes it can get extremely complicated. And I'm going to show you how complex it can get at the end of this lesson. And then in the next lesson, I'm going to show you the way that I split up my data all the time because it is so much easier. But it's good to have this basic knowledge of text functions because you will find yourself using them from time to time, particularly when combined with other functions. So let's take a look at some of them and how they work. Now, in this first example, I have just a small list of part numbers. And maybe I want to split these up. So I have the first 3 characters in the code column, the middle 3 characters in the identifier column, and the last 3 characters in the part column. Now, I could use text to columns to do this, but we're not going to do that. We're going to use text functions. So the first thing I want to extract from this string is the code, and the code is the first 3 characters of this string. So the function I'm going to use here is equals left, because we're going to work from the left-hand side of the cell. We have 2 arguments for this function. The first argument is text. So that is the cell that contains the text we want to extract. And this is a simple case of entering in how many characters we want to extract from the left. So because all of these are consistent, I want to extract 3 characters. Close the bracket, hit enter, and I can simply double click to copy that down, because all of these part numbers are very consistent in their format. They all have 3 characters, 3 characters, 3 characters. Now, if I want to extract the middle 3 characters, for this, I would use another text function called mid. And we have an additional argument here. So our first argument is text, so that is the cell. We then want the start number. So I need to count across until I get to the first character that I want to extract. So 1, 2, 3, 4. I want to start from the 5th character, and then I want to extract the next 3 characters. Close the bracket, Control Enter, and I can double click to copy that down, and I've extracted the middle part of this string. And then the final one, I want to extract the last 3 characters. For this, we use the write function. Once again, we select the text string and then the number of characters from the right that we want to extract. So 3 in this case, Control Enter, and then double click to copy down. Now, extracting text in this way is all well and good. And if you have very consistent numbers or strings, then this works really well. It's super simple to put together. But more often than not, you have data that isn't consistent. So let me show you an example. And again, if we take a look at this data down here, maybe this is something that we've imported. We basically have 4 pieces of information combined into one cell and separated by a comma. So if I want to extract the employee name from each of these cells, I'm not going to be able to do it using the left function. Because if this works for the first one, so let's say left, I want to extract from this cell number of characters. Well, for this first one, if I want to extract the entire name, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 characters. We need to count the space as a character. So I could type in 9, close the bracket, hit enter, and whilst that works for the first one, when I copy this down, it doesn't work for the others, because these are not all consistent in their length. And this is where using text functions becomes a lot more complex. So let me show you how I could extract the name from this cell. We need to do something a little bit different. So what I'm going to do here is we are going to use left, but we're going to go about this in a different way. Now we're going to specify the cell A12, but when it comes to the number of characters, we need to think about this in a different way. I can't just count across to extract the number of characters. So what I'm going to do is look at this data and think to myself, is there any common identifier that I could use here? Well, I know that after every single name, we have a comma. So maybe I could find the comma in this string and then extract everything before it, and that would give me the name. So the first thing I need to do here is I need to find that first delimiter, that first comma. So I'm going to use the find command, another text function. Now with find, we have a few different arguments. It's asking us which text we want to find. Well, I want to find a comma. Now, because this is a comma, it's essentially text, it needs to go in quote marks. So I'm going to say, look for this comma. If you had something else, so maybe you've got a space in there, you could type in a space and put that between quote marks. It all depends how your fields are separated. I'm looking for a comma. Where am I looking for that comma? Well, I'm looking for it in cell A12. So let's close that off. And let's also close off our left function. Now, if I was to hit enter just here, I'm going to get that. And if I copy it down, notice that it has extracted the name, but it's also giving me a comma on the end. So what I can do to get rid of that comma, double click to edit the formula, is just on the end here between these 2 brackets, I'm going to say -1 to effectively go back a character. And that's going to get rid of that comma. So that formula just there, if you look at it in the formula bar, it isn't too bad. We start with left, we then specify the cell, and we then just say find the comma in cell A12, extract it, and -1, so we're not including the comma in that extract. So that formula isn't too bad. Where things start to get really complicated is if I then wanted to extract the job title, because that's in the middle of this data. Now, the formula that you need to put together in order to extract the job title using text functions is extremely long, very complicated, and very much outside the scope of this intermediate course. But just so you can see how long this formula is, I've got it over here. So if I click on this and we take a look at that in the formula bar, would you take a look at that? We have so many different things going on there. It's a very long and complicated formula. It does work. You can see it has extracted that job title. But for me, trying to remember this and taking the time to type all of this into a cell is never the method that I use if I want to extract the job title. And in the next lesson, I'm going to show you by far the easiest way to split up your data. So I'm going to jump across there now, and I look forward to you joining me. So now I've spent the last 2 lessons showing you different ways that you can split up data. I'm now going to show you the method that I use 99% of the time. And the reason why I use this method is because it is so much easier than those other methods. However, it's not something that you can use in every single scenario. So it's good to have a backup of using either text functions or text to columns. Now, the function that I'm referring to here, well, it's not actually a function, I should say a utility in Excel, is the flash fill command. And they introduced flash fill in, I think it was Excel 2013, it might have been 2016, and it was like a revelation. And when I'm training Excel, this is always the tool that gets the most gasps, because immediately people can see how this is going to be useful and how much time it's going to save them, because they're no longer having to create these complex formulas to break up their information. So let's start out with a basic example so we can see how it works, and then we're going to apply it to our sales data worksheet. So once again, I just have a list of employee names. And all I want to do here is I want to split up this employee name so I have the first name in one column and the last name in the second column. So take a look at this. All I need to do here is type in the first one. Now I'm going to do Control Enter to stay in the same cell. Go up to the Data tab, and in the Data Tools group we have a button called Flash Fill. Click. Like magic, it copies those down. How brilliant is that? Now there is a couple of different ways that you can invoke flash fill, so I'm going to delete all of those out. Let's just get rid of those and do it one more time. Now what I could also do here is I could type in Mary, go to the cell underneath. Instead of clicking that flash fill button, if I simply start to type in the next one, Excel is going to ghost down what it thinks I want to type into these cells, and if that is what I want, I can simply press Enter to accept that. Again, super quick. The third way I can do this is to type the last names. Let's type in the first one here, so McCoy, Control Enter. I could highlight all the cells that I want to flash fill and then use the flash fill keyboard shortcut Control E to flash fill those names down. So 3 different methods for invoking flash fill. But I think we can all agree that is so much easier than using text functions or text to columns. As I said, one of my favorite things in Excel. So now that we have that under our belt, let's use this in our sales worksheet. So once again, we're back at this stage with this worksheet where we have the country and the product combined. So I'm going to add another new column, Control-Shift+, and let's add another one, Control-Shift+. Let's call this one country and this one product. So now I can use flash fill to fill these down. So we're going to type in the first one, Control Enter, up to the Data tab, click Flash Fill. Like magic, it fills them down. Now what about with Kensington? Because that's in brackets. Let's type in Kensington, Control Enter. Let's click Flash Fill. It still works. So it hasn't brought across those brackets. All that's left to do now is delete out column A, and in literally 10 seconds, I've managed to break up that one column into 2 separate columns. Now it's also worth noting that you can use flash fill not just to split up data, but also combine data. So if we go back to our example, if I wanted to take these two and combine them into one to give us the full employee name again, if I just type in full name over here, we can use flash fill in the same way. So all you need to do is provide flash fill with the format for the first one, Control Enter, and then I can click the flash fill button. Now notice, this is an example of when flash fill doesn't work, and that is because there is a blank column in between my data. So if you have this kind of setup, this is where you might then need to resort to using text to columns or text functions. But it's worth noting, but I wanted to show you that just so you can see one of the drawbacks of using flash fill. So what I'm going to do instead is let's just move this across, and now I should be able to flash fill down, which I can because the columns are next to each other. So really important, if you have a blank column in the middle, flash fill is going to struggle to know what to fill down. But otherwise, this is a brilliant utility. In the last 3 lessons, we've spoken mainly about how we can split up text strings, and we've seen lots of different methods that we can use to do that. But what about if we want to do the opposite? Well, we saw how we can use flash fill to combine values together, but we can also use a text function called CONCAT. And you would use CONCAT whenever you want to join values in different cells together and make them one string. Now, before we get on to using the CONCAT function, let me show you another way that you can join text strings together. Because we can simply use the ampersand symbol to join cells together. So for example, if I want to join together the first name and the last name, what I could do over here is type in equals, select the first cell, and then I could use the ampersand sign. So if I do ampersand and select the second cell, so this time the last name, that's going to join these two text strings together. Now if I press enter, let's take a look at it. Well, yes, it has joined them together, but I don't have a space in the middle. So I also need to account for the space. So let's double click to edit the cell. What I need to add in here is after the first ampersand, I need to specify that I want a space between the names. Now space counts as text, so it needs to be enclosed in quote marks. So quote, space, quote, and then another ampersand to join the space with the text in cell B4. So now when I hit enter, I get exactly what I'm looking for. And I could copy that down and it's going to do the same for all of those names. So you can use just an ampersand symbol if you want to join text strings together, but you need to make sure that you do account for things like spaces, dashes, commas, things like that. So very straightforward. Now concat allows us to do something very similar, but this time we're using an Excel function. So let's do the same thing, but this time we're going to use concat. Now when you start to type in concat, you'll see that you get 2 things come up in the list, concat and concatenate. Now concatenate is what this function used to be called, and they changed it a few years ago to concat. But concatenate does still exist in the Excel database, but know that it has a warning symbol next to it, letting you know that that is kind of an old function and concat is the newest version. So concat works in a similar way. Our argument is the first piece of text, so we want the first name, comma, text 2. Now again, if I was just to select the last name and close the bracket, it's going to give me that with no space. So what I need to do in here is my text 2 needs to be the space. So again, quote mark, space, quote mark, comma. And then when I hit enter, I'm going to get the format that I need. So slightly different to using ampersands, and I'll leave it up to you which of those methods you find easiest to remember. Now just to finish off this exercise, let's take a look at a slightly more complex example. Now this time I want to concatenate the name and the job title, and this is the format I want to use. So I want a space separating the first and last name, and then I want a space dash space and then the job title. So let's do this both ways. If I was just using the ampersand symbols, what I could do here is I could say I want A4, ampersand. We need a space in there. So quote marks, space, quote marks, ampersand. Then we want the last name, ampersand, and then we want space dash space. So quote marks, space dash space, close quotes, ampersand, and then we want the job title. So we can select the cell. Let's hit enter and we get exactly what we're looking for. I could then copy that down for all of the others. So that is how we would use the ampersands to concatenate slightly more complex text strings. What about if we were to use the CONCAT function for this? Is it any simpler? Well, let's see. Text 1 is Mary, comma. Remember, our space is our next piece of text, so quote mark, space, quote mark, comma. We then want our text 3, which is the last name, comma. Then we want space dash space, so quote mark, space, dash, space, close quote mark, comma, and then finally we want the job title. Close off the concat function, hit enter, and again we get exactly what we're looking for. So that is how ampersand and concat work. So now we've seen how we can join text together, let's take a look at doing that on our sales worksheet. So just for this example, we're going to concatenate the country and the product name again. So let's add in a column, Control-Shift+, and let's use concat to do this. So I'm going to type in concat, text number 1. So our first piece of text is going to be the country. Now I want this to have space and then I want the product name, but I want the product name to be in brackets. So my text 2 is going to be a space, quote mark, space, quote mark, comma. What is my text 3 going to be? Well, I actually want a bracket in there. So again, in quote marks, because a bracket is considered text, I'm going to do an opening bracket, close the quote mark, comma. Then I want the word Kensington, comma, and then I want a closing bracket. So quote mark, close, quote mark, and then close off the concat function. Now that looks like a really weird function when you just look at it with all of these quote marks in there, but hopefully when we hit enter, we're going to get exactly what we want. And we do, and we can double click to copy that down. Now just for fun, let's see what that would look like if we were using ampersands. So equals Japan, then we want an ampersand, then we want a space, quote, space, quote, ampersand, then we want an opening bracket, so quote, bracket, quote, ampersand, then we want the product, cell B2, ampersand, and then we want our closing bracket, quote, closing bracket, quote, and that is it. Hit enter and we get exactly the same thing. So once again, I will leave it to you as to which of those methods you prefer. Now we don't actually want to combine these like that, so I'm just simply going to delete out that column. For me, Excel tables are one of the best things in Excel. And the reason why I love Excel tables so much is that they take a lot of the hard work out of formatting and organizing your data, and also they help you update data super quickly. So we've already seen how we can put data into an Excel table a few times throughout this course, but I just want to recap it in case you did miss that part. And I also want to show you why it's so important that you put your data sets into Excel tables. And this is my number one recommendation. Whenever you import data and you clean it, the last step should be to not only spell check it, but also put it into an Excel table. It's going to make your life so much easier when you then start to build pivot tables and charts based off of this data. So I want to start out just by showing you a quick example of creating a table and why it can be so useful. So I have a very tiny data set here. I have a few countries listed and I just have some sales figures for these countries. And what I want to do is I want to put this little piece of data into a table. Now, all I need to do here is click within my data and press the Control-T keyboard shortcut. Now, really important, make sure that you select My Table Has Headers if it does in fact have column headings, and click on OK. Now that is going to format your data as a table. Now, how do I know it's a table apart from the obvious formatting? Well, I can see that I now have a table design ribbon appear at the top. And this is one of those contextual ribbons. If I'm clicked somewhere else on the worksheet, the table design ribbon disappears. If I'm clicked within my table, it reappears. And basically on this ribbon, I have all of the commands, all of the formatting that I need for this table. Now, I don't particularly like banded rows, so the first thing I'm going to do here is turn those off. Now, my next tip is to always name your tables, because by default, when you create a table, Excel is going to assign it a very generic name. And you can see here on the table design ribbon in the properties group, this table is currently just called table 1. If I was to create another table, it would be table 2, so on and so forth. Now, these table names are very generic, they're not very meaningful. And when you get a bit further down the track and you start trying to identify different tables to use in things like formulas, it's going to be really hard to know what table you're referring to if you just have them called table 1, 2, 3, 4, 5. So you want to make this more obvious as to what the table contains. So I'm going to just call this, sales underscore data and hit enter. Now, a really important point when you're naming your tables, you can't have any spaces in your table names. So if you have two words like I do here, you need to separate them with an underscore, or you just need to remove that underscore and have it all as one word. So super important to name your tables. Now, what is the biggest advantage of a table? Well, one of the behaviors of a table is that they auto-expand. And what that means is that if you add any additional data onto the bottom here, the table will expand to accommodate that new data, and the new data will essentially become part of this sales data table. And what that means is that if you've created maybe a chart based on this table data, the chart will automatically update with the click of one button to include the new data that you've added. So it makes everything a lot quicker. So let me show you that in practice. Now I'm going to quickly create a column chart. So let's go up to the Insert tab, into the Charts group, and let's just select this one here. Now, if you've never used charts before, don't worry, we have an entire section dedicated to building charts a bit later on in the course. But this is a fairly standard chart. It's just showing my figures for these different countries. Now, I'm not going to do anything fancy here. I'm not going to start formatting it because the entire point of this little exercise is really just to show you how easy it is to update charts when you add new data. So because my data is in a table, if I was to click underneath and add a new country, so let's just say Brazil, press the tab key. Notice as soon as I do that, Brazil becomes part of the table and it's automatically been updated in the chart. I haven't yet added my sales values, but as soon as I do, let's just say 20,000, it's going to add that bar to my chart. Now, if I hadn't put my data in a table, this chart wouldn't behave like that. So let me show you what I mean. I'm going to undo a few steps here. So this data is no longer in a table. Now what I could do is I could select the data, go up to Insert and create a column chart. Everything looks the same so far. But if I then add Brazil onto the bottom and press the tab key, notice my chart doesn't update. And that's because I've created this chart based on this range of cells. And by default, a range of cells doesn't auto-expand to accommodate anything new that you add, whereas a table does. So that is one of the reasons why I love using tables so much. They just take a lot of the hard work out of it for you. So let's jump across to our Format as Table worksheet, and we're just going to finish off our sales data spreadsheet by putting it into a table. So let's click in the drop-down. Now remember, you can press Ctrl-T to create your table. Alternatively, you can jump up to the Home tab and go to the Format as Table drop-down and choose one of the tables from the gallery. Both of these do exactly the same thing. So what I'm going to do here is let's just select this table. Yes, my table has headers. Let's click on OK. And if you look at that table design ribbon, we have numerous things we can do here. So if I decide I want to change the table style, I can click here and I can change it to something else entirely. I'm fairly happy with it being green. I can then choose some table style options. Now I could toggle off the header row if I wanted to. I'm not going to do that because the header row is extremely important. I could add a totals row from here. I can toggle off and on banded rows. So if I don't like that banding, I can turn that off. I can make the first column bold. I can make the last column bold. I can even choose banded columns. And if you're wondering what these banded rows and columns are, a lot of the time these can really help with the readability of your worksheets. So some people love these, some people don't. I can't say I'm a fan. I normally turn these off. And if you don't like that filter button at the top there, you can toggle the filter off as well. Now, some other things of importance on this ribbon. We can do things like insert slicers. Now, a slicer is simply a visual filter. And we're going to be talking about slicers when we get to the pivot tables section. So I'm going to hold off from speaking about that too much at this moment. Now, what I can also do from here is I can create a pivot table. I can remove duplicates. So I think we did this already. Let's click on OK. There we go. 2 duplicates found. I can remove those at this stage. And as we've seen, if we want to take this data out of a table and just convert it to a regular range, we've got the Convert to Range button just here. And then finally, we have the Properties group where we can give our table a name. So I'm going to call this table Product Sales and hit Enter. Now, the final thing I would probably do here prior to putting this into a pivot table or creating a chart is perform a spell check. So we can very quickly invoke spelling by pressing the F7 key. I'm going to say yes to continue checking, and I don't have any spelling errors in this worksheet.
If you're not a subscriber, click down below to subscribe so you get notified about similar videos we upload. To get the course exercise files and follow along with this video, click over there. And click over there to watch more videos on YouTube from Simon Says It.